Good morning, everybody. This is Dr. Robin Beeman from James Cook University, welcoming everybody to join us on dive 401 with the SuBastian, diving to a target depth of around 560 meters on this newly discovered, approximately 500 meter tall reef on the Great Barrier Reef. This is a detached reef. It's one of a collection of 7 that we know of so far. These detached reefs are quite special. They're at the very far northern reaches of the Great Barrier Reef, offshore of an area of Cape York Peninsula. And we discovered this reef just a few days ago while we were mapping here. And well, like I tell everybody, it's not every day you find a 500 meter tall reef inside the Great Barrier Reef Marine Park. It's funny though, when we reached out to all our colleagues ashore, and there's quite a big collection, geologists, marine biologists, everybody had their take on how what we should be doing. So the geologists want to know how old it is, how it got to be here, which is quite an unusual story in itself, we think. And of course the biologists really want to know what's down here. I guess the beauty though, we've got Marty McNeil here with me. The beauty of the SuBastian is we can try and answer all those questions, can't we?
Yeah, we can attempt to. We won't know the age, of course, until we take the rocks home to the lab and try and get some ages from them, or some comparative relative ages. Yeah. Rob, did you want to talk a little bit about why this is newly discovered, in the sense of we have some mapping from this area? Maybe talk a little bit about data points and resolution and why this reef was invisible before, but now it's been revealed.
Yeah, that's right. So it all comes down to how you map the seafloor. And for much of the Great Barrier Reef, the shallower coral reefs on the Great Barrier Reef, they've been mapped quite consistently over the last 2 decades or so by the Royal Australian Navy and the Australian Hydrographic Office using airborne lidar bathymetry. And so we actually have quite a good understanding of the shallow reefs themselves. Now this detached reef, it's just sitting, we believe the top of it is around 40 meters depth. Now this is kind of at the lower limit of lidar detection out here. So lidar being laser beams, and just a quick update on airborne lidar bathymetry uses red and green lasers. The green lasers can actually penetrate through the water column, and if they detect the seafloor within that sort of 40-50 meter zone, you get a bottom return. The red laser is fired as well underneath the aircraft, and it gives the aircraft an idea of the height. So the difference between the two, the distance between the red laser, which reflects off the sea surface, and the green laser, which reflects off the seafloor, is effectively the depth of water. So in the vicinity here, we've got the closest detached reef, one of these really tall reefs, is the northern small detached reef. This reef is about 5 kilometers out from the east of the edge of the Great Barrier Reef. So I think the Great Barrier Reef, it's just sitting on the Australian continental shelf. And then there's this big, deep ledge. Now this ledge, we've only really been mapping for the first time here because of the modern mapping tools that are on board the Falkor. And I'm talking about multi-beam echo centers. Just looking at the vision here, these are hatchet fish. Yeah, and we've seen them in many dives. Look, we'll continue to give you a little bit of background story, but of course, if anything pops out like this, we'll stop and talk. We stop for lots of things, don't we?
Quite a swarm of them here, isn't there?
Yeah.
Often we see 1 or 2.
So we're just cracked 500 meters. The seafloor will come into view very shortly. Yeah, but these are hatchet fish. Have a look at them on the internet. They are really quite strange looking animals. They have very, very shiny, reflective scales, I imagine. They're not big, they're quite small, but we've got a real collection right in front of us. And they've got very strange looking eyes, don't they, Marty?
Yeah.
If we get a close-up look at them, all their eyes are pointed upwards.
They're fast.
Yeah.
Not easy to.
So in this 500 meter depth, if we turn the lights off, it's completely black. But of course, if animals like this are looking upwards, they will probably see a very faint reflective light coming down through the depths. And this is what they use. They can use it for hunting. Looking for silhouettes of animals above them.
It's too quick.
Yeah, bit quick. So just getting back to the mapping, the Falkor has been working on in this expedition. This is the northern depths of the Great Barrier Reef. We've been really wanting to get up here with modern multi-beam technology for many years. I have done many transits on other vessels, and that's usually all they are.
Here we go.
It's a
Great shot.
good look. Yeah.
Here we are.
Yeah, and the interesting thing about the fish is they've got these photophores underneath. They've got bioluminescent bacteria in those photophores, and so by shining themselves on the underbelly, animals below them are fooled by having that counter shading masked out by, there's a squid going in the background. There's quite a lot happening on the seafloor here.
It's busy here.
I'm trying to talk about the seafloor mapping.
Bodes well for the biodiversity that we might see on this new reef.
Yeah, and so the Falkor really is the first multi-beam capable ship to get into these offshore Cape York waters. We pitched it as a frontier zone.
Yep.
It's definitely a frontier zone. Oh, here we go, the seafloor coming out.
Now.
From a land perspective, the Cape York Peninsula is a frontier zone. It's very sparsely populated. There are indigenous communities, there's cattle stations, there's a few service towns, but a lot of it is wilderness and national park, and not a lot of people there.
No.
And in these offshore waters, very, very few people come here.
We've had a real sense of that isolation, haven't we, while we've been out here, especially when we did our trip up to the Torres Strait to Horn Island to refuel.
Yeah, so we've
we
just
certainly felt like we had the seas well and truly to ourselves.
Yeah, I mean, we've been up here for, this is our third week, nearly fourth week. We have not seen a single ship in the vicinity. That's not to say ships aren't there. They tend to they use what's called the inner route of the Great Barrier Reef, and it's quite a merchant shipping channel. But that's all on the shelf itself. Where we are is offshore, and so there has been no multi-beam mapping out here, but there has been LiDAR mapping over the shallow tops of these detached reefs. So I mentioned that the closest one that's been mapped previously is this northern small detached reef. It's about 2.5 kilometres from where we are right now. And the top of that was actually only mapped about a year ago by Lads Flight, which was based in Cairns, run by a colleague of mine, Mark Matthews, who's a commander in the Royal Australian Navy. And so those shallow reef tops are mapped, but they didn't pick up this one.
Yep. So we mapped the top of this being in about 40-ish metres.
About 40 metres is what we measured, a
which
shoal depth.
sometimes can get picked up by the LiDAR, but not in that case.
You have to kind of be looking in the right place. And for us, with the Falkor, we wanted to 100% map this area, right? So we're talking from the shallow edge of the reef all the way into the deep waters, and then way offshore at the very far eastern limits of the Great Barrier Reef Marine Park. Now, people might be surprised the Great Barrier Reef Marine Park is a very, very broad, it's a huge area. It's about 365,000 square kilometres. It stretches over 2,500 kilometres north to south. It encompasses all of these ecosystems from the shallow coast across mangrove fringe into seagrass beds, the big inter-reef environments, the reef lagoons, and of course this vast maze of coral reef which stretches that entire distance, in fact all the way up to Torres Strait, where we visited the other day. It encompasses these deeper waters, and so it is still a surprise to find.
In fact, these deep areas comprise a far greater percentage of the actual Great Barrier Reef Marine Park that is managed by the Great Barrier Reef Marine Park Authority.
I often tell people, about 50% of the marine park is deeper than 50 meters. Right? So if you spend all your time looking at the shallow coral reefs, you're missing a very big proportion of the remaining Great Barrier Reef Marine Park. But to actually map it and view it, you need modern tools like we have on the SuBastian, on the Falkor.
Yep.
So the Falkor has the multi-beam mapping tools, and we have been 100% mapping this deeper ledge where we are now. And
we've been doing really systematic surveys.
Systematic.
Which again is something that's not been done here before.
Yeah,
It's
absolutely.
just been the odd occasional transit through the area.
That's right.
Which would collect a long, narrow strip of multi-beam.
Yeah, and you only get a glimpse of what's down there. It's almost like, imagine looking through a window with Venetian blinds, right? If you're looking beyond the window, you're just getting little thin strips of what's beyond the window. You really need to open those blinds fully, and this is what we're doing with the multi-beam sonar, and we get a full picture of what the shape of the seafloor is like, and that's how we discovered this new 500 metre tall detached reef. And now we're going to have a look and see what's there.
Of course, is the next most obvious question. What is there? What does it look like? What's the rock type? What's living on it?
Yeah.
How does it compare to some of the other sites that we've dived on this expedition? Can we match up any correlations at certain depths to things that we've seen before on other dives?
Yeah, that's right. So as scientists in a new area, I mean, we take on this role of observers, keen observers, and we're just trying to make sense of the trends that we see.
We're collecting pieces of a jigsaw puzzle, and the more pieces of the puzzle that we can try and put together helps us to unravel the story of the geological history and of course the biology and biodiversity.
Yeah, and there's an insert now that it's a movie that John has put together. So right in the centre of the screen is this 500 metre tall cliff. You can see the one just to the right now. This is this northern small detached reef. That little bit of red at the top is the LiDAR mapped shallow reef that's just capping the top of it. So in fact, we were the first ones to map all around this, the northern small detached reef, the one that was marked on charts, but this other one that's right in dead center of that insert now, we didn't even know it existed before. And so we are, there's just a transparent chart over the top just to show that there was nothing known previously here. So we're just starting the very bottom of the dive. We're going to be here all day. What I like about these 500 metre long vertical transects is we're going to go through a number of different oceanographic zones, aren't we, Marty? So what are we in at the moment then?
Well, at 500 metres depth, we're certainly sub-thermocline, we're below thermocline waters. Depending on geographically where you are in the ocean, we may be in the sub-Antarctic mode water at the moment at 500 metres depth. And then as we ascend above that, we'll probably pass through maybe a thermocline, but sometimes it's a salinity gradient, so it's a difference in the density of the water based on how saline the water is. And then we'd be potentially into subtropical mode water that would take us from about 400 metres up to about, it varies, but about 100 metres, and then above that we're into that shallow surface mixed water.
Yeah, the warmer surface waters. So the thermocline seems to be fairly consistent around about that 400 metre mark, isn't it? So we're just below that.
So the temperature here now at the moment is 8.7 degrees Celsius, and on the surface at the top it's about 26.5, getting close to 27 degrees surface water temperature. Yeah,
and it's a lovely day up here. We've had great weather in the last 2 days, haven't we?
It's been phenomenal, yeah.
Yeah, there's very little wind. The Great Barrier Reef shelf is only about 5 kilometres just west of us. We can very easily see the coral reefs with all their beautiful colours. Yesterday was probably my highlight mapping day. We use a range of sonars to map around the edge. We have a forward-looking sonar, that's kind of a safety sonar, and it allows us to see exactly where the shallow reefs are. And then we have the actual multi-beam sonar, which is collecting this lovely 3D topography that we use to guide where we do our dives. But yesterday we're just kind of cruising along all day around the edges of Great Detached Reef. Oh, here's an inset. This is just fisheye view off the back.
It's off the back of the A-frame.
Yeah.
There we go.
I call it water skiing weather.
Yeah.
Because it's just, you could water ski. It's just like a swimming pool out here.
It's so enticing and tempting to be so close to these reefs, but of course we can't jump in the water and go for a swim from.
We don't do any diving, unfortunately. There's no diving or scuba diving or swimming here, but could easily have done that.
Us, but we have to stay safely on board the ship. Just say good morning to a few people online that are watching on Facebook and YouTube. There's a few family members that are logged in. Oh, here we go, shrimp party in the water column. That's new. Hi to Greg Beeman is online. That's
Greg, my brother.
Yep, and Gail McNeil, Bob and Gail McNeil. That's my parents at home in New Zealand. Hi to you. And lots of regular viewers we see on the YouTube chat. Hi to all of you regulars. Good morning to John and Will at CSIRO in Hobart that are our fish experts. Nice to see you online, and hopefully you'll be helping us out with all the fish IDs throughout the dive today, which is really fantastic. And of course all of the armchair experts that are on YouTube that are also help us out with
we
identifying.
definitely appreciate armchair experts, and that's been a real joy, hasn't it, Marty? Just the people who are speaking and giving us advice and telling us what we're looking at, because we only ourselves have a limited range of expertise.
Yeah, that's right. I mean,
we're a small science team at the moment. There's myself. I'm a marine geologist. Marty, how would you describe yourself?
I guess broadly a marine geoscientist. So my specific interest is in the rocks and sediments in these reef environments. So essentially limestone reef rocks and sediments, and that might be the modern environments in today's reefs, Great Barrier Reef or tropical reefs, but also fossil reefs from the geological past.
And we've got Vicky Lowe from University of Queensland, and Vicky's doing a PhD on Southern Ocean radiolarian diatoms. Is that right, Vicky? Just radiolaria. So a long way from the cold waters of Southern Ocean. But Vicky wrote a really interesting blog the other day, which you can read on our cruise site, just to talk about these colder waters that we find here. It's interesting. What have we got there, Marty? Looks like an urchin. I
think it was an urchin. Yep.
Made a little nest in the sand there. And then we've got Valerie Cornett and Joan Lee from our postgraduate students from James Cook University. So it's only an onboard science team of 5, but we're also going to be joined by Luke Nothdorf from Queensland University of Technology for leg 3 of the voyage.
That's right.
And of course we have the Great Falkor team here. We've got Chris and Cody in the ROV seats next to us.
So what we're doing at the moment is we've descended down to the seafloor on the flanks surrounding this 500 metre reef. So we wanted to have a look at the sediments on the seafloor and see what they were comprised of, and that's why we took those 2 push cores that we collected earlier. And what we're doing now is we're transiting along a transect towards the base of the reef proper, and then we'll begin our ascent up the side flanks of that reef. The gradient will be a little lower gradient to begin with, and then a steeper gradient as we get to the real sheer face of that reef slope, and then we'll make our way towards the top and see what's on top.
The insert's just showing some of the previous mapping that we've done earlier on in the voyage. This is Tideman Knoll. I think it was our first dive on leg 2, and then we've moved further north. You can just see how rugged this landscape is. This is off Cape York Peninsula. We always thought this might be the case, but to actually see it in reality has been just something else.
So what we're looking at here is one of those high reflectance examples that we saw in the multi-beam backscatter. Potentially this is where a boulder. It's a chunk of reef rock by the looks of it.
Looks like it's rolled down
Rolled
slope.
down,
In fact,
yep.
you look up slope, you
And
can almost see
the track where it's
trail.
come from.
So it's slid down and come to a stop, and it's got a whole lot of interesting shell
Very
debris
cool
around
shell
it.
debris around it.
So what are we seeing here, Marty? It looks like, could they be urchins?
They look like urchins, but it's interesting that they've all accumulated together like that.
Yeah. But the interesting thing, other thing interesting is the scouring around it now.
Yeah.
And this happens in higher currents, where you get high currents of actually, you get what's called like a comet tail. You can actually see it in three-dimensional topography. And I think we were getting a hint of this in our multi-beam data, weren't we?
Yeah.
There's fish having a gulp of the back.
So we'll have a quick look for anything that's using this boulder as habitat.
Well, there's shrimps.
There's some shrimps there before we move on and continue on our way. But
Yeah, just curious. Just a whole range of coarse debris around the base. Just trying to get a closer look. Yeah, they look like urchins to me.
They
You know the urchin tests as they break up. They're actually quite fragile.
yeah, yeah,
And they have that
These-
flat look about them.
yeah. They look like infaunal or semi-infaunal, meaning they burrow into the sediment.
Yeah, I mean, sand dollars is
Yeah,
probably what
that's
people
right.
are familiar
Yep.
with on a beach. And sand dollar is just a flattened version of an urchin. There's quite a bit of all kinds of stuff in here. Yeah. Well, these look like pencil urchin
They
spines.
do, yeah.
Oh, there's a fish. Fish's tail. I wonder if it's one of these scorpion fish. We've seen these
Yeah.
deep scorpion fish with that sort of yellow coloration. All right, I think these are stylastrid hydrocorals, those little delicate ones up there. And then we got some sponges. These will be siliceous sponges.
So we're always on the lookout for hard surfaces, aren't we? Rock outcrops or boulders like this tend to be where particularly sponges and other things can make use of those as habitat.
Well, there's lots of little nooks and crannies. It looks like shrimp or squat lobsters hanging out of some of these holes.
So our depth is 564 metres below sea level at the moment, and we'll be making our way up to about 40 metres towards the very end of the dive, as long as conditions hold out and allow us to get that shallow.
Yeah, you can see a
Yeah.
shrimp antennae over the back there. Yeah, so our sample targets today, we want to. I wonder if it's a top shell. We have a colleague, Patrick from Belgium, who's interested in slit snails, which is quite an ancient group of gastropod mollusks. So we need to keep an eye out for those. We'll continue
Nice
on. We got a
urchin.
bit of a drive today, haven't we?
Yeah, we've got a bit of ground to cover before we get to the base of this reef and start the climb.
Yeah, I definitely think that boulder's left a bit of a trail behind.
Yeah.
Yeah, so we've got about a kilometre in horizontal distance to cover, and as Marty said, we're at the very base of it. The base, if you think, I was trying to describe this to my wife last night, what it looks like. You know those Western movies
Oh,
where
yeah.
that particular area of America
Yes, I
where
know
you have
exactly
those
what you're
big
talking about.
mesas.
Yep.
You know, John Wayne comes riding over the desert on his horse. That, you know those mesas?
Yeah,
They're
yeah, I know
flat top.
exactly what you're talking
They've
about.
got almost vertical sides, but they've got very broad bases.
Yeah. And
That's
that
what this
is
looks
an
like.
excellent description of what this reef looks like.
And Luke's joined us. Morning, Luke. Luke's not far away from driving up to or flying up to Cairns. Yeah,
Got
we
the
need to
pointer there.
have a look.
Let you hang on to that.
Okay, I wonder if this is a black coral. I wonder if Jeremy
Buttes in Montana.
Jeremy has
Buttes
joined
is
us.
the word that I was trying to think of too. I was racking my brains
Buttes.
back to first year geomorphology, trying to remember what they were called.
Right.
Yeah.
It's not butts. I haven't got that. It's boots.
Butte. Yeah, Butte.
Butte. Okay.
Yeah.
Just been corrected by our Florida team member, Chris. We've also got the Texan team on board with Cody and J-Rod. Learning all about New Orleans last night. It was entertaining.
Yeah. Plenty for the travel bug within me to want to go and explore.
Because we have such a big international group on board, the Falkor's team, from really all over the world. It's
that's right. Although Falkor's been in Australia since the start of the year, and although we're sort of an Australian science team, we're certainly almost in the minority on board. We've got a very diverse range of international crew.
Just
and
me and
scientists.
Vicky,
Yourself
I
and
think.
Vicky are the Australians on board.
Sole Aussies.
Yep.
But the Falkor has been out here for a year-long series of expeditions. Started in, I think, December when it first sailed from Fiji into Sydney, and it was always committed here for a year. Mm-hmm. It's amazing that here we are, late October, November. I've been involved with 3 of those expeditions. So this is, in fact, the 3rd expedition out in the Great Barrier Reef and Coral Sea. But if we just wind the clock back to January period, the Falkor left Sydney, sailed underneath southern Australia to the southwest corner of Western Australia, and did some spectacular ROV dives in the Bremer Canyon.
Yes.
This really deep canyon, 3,000 metre plus canyon that drains into the Southern Ocean. And that was when I guess became first familiar with the SuBastian and the live feeds. I remember watching, the black rock landscape and some of those whale falls, dead whale skeletons that were
I missed that.
bottom of the Bremer Canyon,
okay.
and all that weird fauna that's associated with organic skeletons, breaking it down over time. And then it went around to the Perth Canyon, just opposite the city of Perth, another couple of deep dives there, and then went up to Ningaloo Canyon with Nerida Wilson and a big team from the Western Australian Museum. And they had a pretty amazing time by the sounds of things. Lots of quite spectacular finds, including a sophonophore that was tens of meters long.
Right.
One of the world's largest animals. In fact.
Mm. Yeah, it was the Ningaloo Canyon dives where I started to tune in and be following along.
So there's a little hermit crab over on the right, but it's in a scaphopod, which is a cast-off tusk shell. So it's a gastropod that lives up in the high plankton, and they die and they drift down onto the seafloor. But it's taken over the tusk shell.
I've never seen a hermit crab in a tusk shell before.
Yeah. Usually like the other gastropods, big brown gastropods. So we've got some nice brittle stars here. And this epifauna we're seeing constantly. Any of these larger colonies of animals, like the colonial cold water corals and soft corals, are used by other animals as habitat. It's a cup coral here.
Mm.
And a sea cucumber coming into view. So we're fortunate to have Joan Lee on board. Joan is doing a postgrad project on using drone imagery to identify sea cucumbers in shallow lagoon environments. So Joan has written a blog, and will come out on the cruise page in the next week or so. But we'll get everybody else from the team on talking through the day.
We certainly will.
Everyone will have a chance to talk and chat about their favourite critters. But this sandy environment is not devoid of marine life, of course. It's just different to the hard rock faces that we see on the steeper slopes. And I really enjoy going across these soft sandy environments. There's always, you know, because the trails are left behind. This is this Lebensburn.
Yeah.
Life
Is that an
traces.
urchin or is
What
that
have
a
we got
Nautilus
here?
shell?
Is this a Nautilus? Yeah, it is.
Yeah,
it's a
it
Nautilus.
is. Nautilus shell.
Just a dead shell.
Yeah.
It's lost some of its colouring, but it's got that classic coiled look. Okay,
Yeah. Yep.
fingers crossed. We see a live one.
Maybe where there's a dead one, there has to have been a live one.
Yeah. There's an animal living inside it. Yeah, like an anemone, just withdrew its tentacles right in the middle. See the top there?
Ah,
There's
yeah.
something. It's like an anemone attached to the outside. Right in the middle of the coil there.
Mm-hmm.
Excellent. All right. Well, we have seen living Nautilus on this northern depths of the Great Barrier Reef, but we've also seen quite a few of these dead shells as well.
We have, yep.
Lots of tracks and trails here. This is this life traces, the Lebensburn. Probably left by either sea cucumbers, holothurians, or
sea urchins.
sea urchins. Sea urchins leave quite a distinct. They burrow in the seafloor and leave quite a good trail behind. There we go. A lot of fish so far, isn't there?
Yeah.
Okay, it's less muddy, and we're getting a bit of ridging going on here now.
Yeah, sometimes it takes a little while to get your eye in just to determine whether that ridging is bioturbation, these Lebensburn, or whether it's bed forms. Getting a hint of maybe some ripples there now. Bed forms ripples, they're a sign of water movement, so it shows us that there's currents in this area that are sufficient to move the sediment and form it into ripples.
It's looking more scoured to me. I'm not seeing that soft sediment that we saw right at the very beginning of the dive. So we're just starting to come up the base of this 500 meter cliff.
Here we go.
This 500 meter reef. So we're going to see it slowly gets more steep.
See some tentacles of something hiding in under there, about to come into view. Shrimp.
Shrimp home. Yeah, it's an ice urchin coming here. There's something looked like a hermit crab just ducked into a hole on the right. Yeah, well, we're definitely in the Nautilus depth zone. We've seen them between about 300 and 800 meters depth. You know, when I look back over all the ROV dives that we've done in the Coral Sea. So during the daytime, they're down in these deeper waters. Now that's
A
unusual.
cucumber? Can we just... or is that a pod?
Looks like a bit of vegetation.
Almost looks like a mangrove seed, mangrove pod
Yeah.
or something.
Looks like a bit of vegetation next to an urchin. Yeah, they have the. So we've seen. Yeah, this looks like a black bean.
Which would come from a rainforest
A
tree.
rainforest. This looks like a rainforest seed pod. Something called a black bean. If you split it open, they look like little boats in between. I give them to my kids to play with. You can actually, you know, they float down a stream, and they're a classic North Queensland rainforest tree. You know, quite a very tall tree. Anyway, that's what I think it is.
And another very cute little hermit crab.
Yeah, sitting on top of an old urchin shell. There's just a lot of shell material on the seafloor here.
Yeah.
We have seen vegetation in some of these other dives, mainly in the canyons, haven't we?
Yeah, yep. In those shelf-connected, shelf-incised canyons, they're acting as a transport conduit between the shallow continental shelf and the deep basin.
Yeah.
And on some of those dives, we've seen a lot of vegetation and other debris, including plastic.
Yeah, we did see plastic, unfortunately, which is a bit of a mystery because in this area, not a lot of people, so the plastic has to have been just brought there by surface currents and the like. Well, it's getting more rubbly.
Yeah.
Lots of urchins.
Lots and lots of urchins.
Yeah. Well, we've seen living ones. There's, I guess, when they die, they just stay there. You know, the shell just stays there until unless
nice one.
Currents move. There's another one over on the right. Okay, so that's good to know. Like we're seeing lots of urchins. That's more vegetation we just went over.
Yep.
Now
Another
Nautilus coming
shell.
into view. Just coming into view, you can see the tiger striping on the side.
Yeah.
It's quite a small one. Cool. Pretty old.
Yeah, it's been there for a while. It's not a fresh one.
Yeah, it looks like it's got an anemone or something sitting
Almost
on
looks
top.
like a barnacle sitting on top.
Yeah. There's a lot of class.
Rubble.
You know,
Yep.
rubble, yeah. Yep, I agree. It looked like a black bean seed. So, like I say, when you split those seeds open, they've got the really large seed sitting in, it's kind of nesting in the middle. But each half of them looks like a little boat. So, kids in North Queensland they float them down streams and the like.
Might just give this
we just
substrate a poke.
Yeah, can we just see how hard or soft this? Oh, well, this is another urchin with a fancy hat.
Anemone hat. We've seen a few of those now, haven't we?
Yeah.
On different dives. We often see them almost on every dive.
Yeah. Would you mind just putting down here, guys, and
Just give it a tap. Is
Yeah.
that?
It's hard.
It's hard.
Yeah, it is bounced.
Yeah. Right. Okay.
All right. Just do some push-ups. Drop and get me 20.
There we go.
Okay.
Okay. Well, if you see a bit that looks grabbable, could you please try and grab a bit?
Yep. Okay, that's good to know. So we're looking at a hard substrate with just a veneer of
Yeah.
soft sediments, and it disappeared pretty quick, didn't it, Marty? As soon as we came up onto this base, this kind of gradually rising base, it became this hard rock surface.
And a nice little shrimp in that hole there.
Yeah.
It's about to have his day interrupted. Sorry,
Yeah.
dude.
Yeah, so we've tried lots of different techniques to pull out a rock here. We've tried drilling, banging, all kinds of things. In the end, we bring out the big claw, the left claw, and just look for a little ledge that we can get the hand under and just lever up.
Yeah, this limestone is very hard. It's been cemented down here, so meaning that it precipitates calcite cement that holds it all together and turns it into rock, essentially.
Yeah, really hard rock
So
too.
very hard.
So we've the guys here made a drill, which was quite effective in other areas, but at times all we were able to do was just polish the rock.
Yeah.
So in the end, the easiest is just to bring out the big claw and try and snap a piece off.
Which is not easy when you're neutrally buoyant and floating
Yeah.
around in three-dimensional space.
Yeah, that's right. You've got no leverage. So the idea is you at least put the ROV on the seafloor, and we got some little bumper bumper bars, don't we? Oh, there's a ship coming in to check it out.
Check out what we're up to.
And of course, a fresh face is important. Otherwise, what you're just getting is the eroded surface, which is much harder to do any geochem work on.
Yeah.
Dougal's joined us. Welcome aboard, Dougal. Dougal's our plankton specialist, joining from Jamstec in Japan, the big marine science agency. And tomorrow we'll have the privilege of having Dougal join us.
There we go. Nice piece broke off there.
For a
Grab them
mid-water
both,
dive.
please, Chris.
Yeah, we're doing our mid-water dive
1A
tomorrow.
would be great, thank you.
Okay, so that's a pretty decent chunk.
Yeah, another piece snapped off. We'll go back and grab that as well.
So we're just getting our first rock sample here, and this is important because we're trying to explain how you get a 500-metre tall reef out here on the edge of the Great Barrier Reef. And the only way you can explain it is that it's very old.
That's right.
Much older than the Great Barrier Reef itself. We're thinking that this is a Miocene limestone or carbonate platform upon which these reefs have grown over long geological time. But the only way to really confirm it is to take a rock sample, and we can do some age dating on it.
Which in itself seems straightforward, but it's certainly not. Lots
No.
of challenges. If the limestone is very old, then it's likely to be weathered and chemically altered, which makes it challenging, if not impossible, for us to date. But we won't know until we get these samples home to the lab. There we go. Great, thank you. And I'm joined in the chair momentarily by Joan Lee, who's a master's student from James Cook.
Hi, hello everybody. I'm Joan, and thank you for the ROV team. The camera pointing now to the ball box too. So I'm just jumping on to say happy birthday to my mom, which is still in the US time zone. Yep, and I'm very happy to have this chance to do this. Kind of help my mom travel to 500 meter depth.
That's a pretty good birthday present, isn't it? Not everyone can say that.
Not everyone can say that.
So happy birthday, Joan's mum.
Yeah. And just now while we're traveling here, we also see a couple of sea cucumbers. So Rob also helped me to pre-introduce the upcoming blog post.
So Joan, you're studying sea cucumbers in the shallow reef,
Yes.
is where you specialise, isn't it?
I wouldn't say I'm specialized in that already.
Specialising as part of your masters.
Wait, Dougal knows Chinese? Thanks,
Dougal.
Dougal. That's very surprising.
Dougal, Lindsay, you are a walking encyclopedia.
Wow.
Wow, that's nice.
Yeah, it's very nice. Thank you, Dougal. Yeah, so back to the sea cucumber. Yes. I'm basically doing just a detection of, in general, the sea cucumber family. I didn't really differentiate it to species level because it's a little bit hard since I'm working on drone images.
So you're doing remote sensing.
Yes, it's all remote
Yep.
sensing, so it's relatively easy for the computer to differentiate those features, such as the contour and then the relatively distinctive sausage shape of sea
Yep.
cucumbers.
Yep.
But they couldn't really tell the difference when it comes to some very similar species, because when they're having similar morphology, such as a lot of sea cucumbers are just like dark or sandy color but smooth surface, then it's very hard unless you can go into the water and see the details on the body.
Right.
Yeah.
So what it gives you then essentially is a presence and absence and the spatial distribution
Yes.
of the...
So with the drone images, it's like the maps we're doing now. It has the geotag with the images. So we can do accounting and basically kind of not real-time monitoring, but a lot more recent, and also covering much larger area compared if you do a transect line in water by a diver
Yeah.
or by mantis atoll.
So are we looking at a soft coral here?
Yes, I would think
so.
Yeah, it's an octocoral with a lot of brittle stars on top.
Okay.
Yeah.
I think we can keep going.
Dougal's mom's birthday as well? Oh, okay.
Oh, it's Dougal's mum's birthday tomorrow.
So happy birthday to
Tomorrow's
Dougal's
gonna be a
mom.
big day.
Yeah.
Yeah. In fact, it's our last dive
Yeah.
tomorrow.
And it will be a Dougal dive apparently,
Yes.
right?
A partial.
Partial.
Right.
And as we're going through the bottom of this area, I think we can, at least for me, I would think the sea cucumbers that we see here are more or less demonstrating the features quite similar to the ones that we see in the shallow reef, because they're all kind of just lying at the bottom and the body is less transparent than
Okay.
what we see in the deeper water. And this is also what I've learned during all these deep dives, is that for those deeper, the sea cucumbers at deeper areas, which we would say more than 2,000 meter, they have more transparent body walls because they have more gelatinous tissue,
Right.
rather than most of the time it's collagen
Okay.
that's
so
in this shallow water. So
collagen is a protein.
It's a
and
they're
is
both
that giving
yes,
them colour.
giving them like yes, color
whatever
or
other
just
function.
patterns on the yes. And when they're gelatinous at deep water, it's more neutrally buoyant than collagen, so it's easier for them to swim around. So that's why when we're
that's why
going
we
to
see all the swimming.
yeah, they're just like dancing in the water.
Fascinating.
Yeah. And I thought like those dancing would be relatively new because the videos are getting so good in just recent days. But apparently in 1990s, people are already in the submersibles and go into the like below 1,000 meter and take pictures.
Oh, really?
Yeah.
Wow. Okay. I think we should try and get more of this rock.
Yeah, it's a nice layer.
So yeah.
Cody, we're going to try and break another piece off the lip of this coral as well, please.
I am sitting down. I kind of guessed already. I'm gonna do it. I'm like, I don't want that.
So all these layers, what's the possibility of them forming this type of layers? It's
Well,
quite
we're looking at
large.
limestone, so
Yeah.
this is reef rock, and it's coated in this black crust, this black coating that it's covered in is a ferromanganese oxide coating on the outside, which doesn't grow at the time when the limestone is a reef, reef rock. It happens later.
When they expose to the water column.
Well, they're in the water column already at the time when the reef is forming.
Yeah.
Not the ferromanganese, the limestone. And so these layers represent, I guess, generations of reef growth I mean, if you go for a scuba dive on a reef, on a modern reef today, you'll see little ledges and caves and outcrops as the reef grows upwards and kind of stacks on top. And so that's sort of what we're seeing here. See if we can snap a piece of this off. It's coming. It's quite. There we go. Thank you.
Where would you like this one?
1B, please.
Try to get that wood next to that.
Shout out to Geological this morning. Well, it's morning here for us. I'm not exactly sure what time it is where you are. Nice to see you joining us on the live stream. So we'll tuck that sample away in the box. So as we ascend up this reef today, essentially towards the base of the reef, it's going to be much older, and as we ascend upwards, it should get younger and younger. But of course, through geological time, over 500 metres of reef growth, within that period of geological time, there would have been sea level oscillations, there would have been hiatuses in reef growth, and then regeneration.
Would you like another piece, Marty? Or?
If there's one that you dropped, or this one.
The smaller rock that's in front of us, or just the bits?
Did it break off with it?
No, I'm saying the smaller one that had the coral on it. Like,
Oh, I see.
popped out a little. Not off the back end.
No, thank
Try
you.
another little bit here, then.
Yeah, so our task is to try and piece together all of these jigsaw puzzle pieces and try and figure out a geological history of when the reef was growing, when it stopped growing, and that would relate to various phases of high and low sea level, and also subsidence, when the whole seafloor subsides due to tectonics. So it's quite a complex interplay that we need to try and piece together. So the more samples we can get, the more information we'll have to try and put that puzzle together.
So I've got a question. How would you decide which one to go to which bio box? Because apparently for our biological sample, we usually decide when we want to avoid the DNA or biological material contamination. But for rocks,
Just trying to keep them separate, because when they come up when the ROV comes up and we get them in the lab, like if we want to try and get ages on the rocks, or separate them out for some reason for geochemical testing, when you come up with just a chunk of rock, it's often not easy to tell the samples apart, and so putting them in separate bio boxes means we can track the sample all the way from when it was collected through to when we bag it and tag it in the lab. And I know for sure that we're not mixing them up, because once they get mixed up, then whatever data you collect essentially becomes useless, because you're not certain about where it came from.
Exactly. But will
sometimes it doesn't matter, so if it doesn't matter, then I can just put it in any box in with anything else.
So will the rock kind of cross-contaminate each other if you're doing geochemistry analysis?
No, it's not so much cross-contamination like it might be with a biological sample for DNA. It's more about, we need to know exactly
Just
what
keep track
depth.
of
we need to know exactly what depth the rock came from to be able to match its geochemical data up with the depth, so that we can try and reconstruct that sea level component that I was talking about before. So if we collect a rock from 500 metres and a rock from 100 metres, and they look superficially very similar, and they're in the same bio box, and then they get mixed up, and then the data between the two becomes useless.
They look exactly the same, so I understand.
Yeah, something deeper that's younger than what's above. That's pretty unusual.
Shoulder down.
So what are we looking here?
Yeah, this is just an insert view of the.
Here we go. Did you want to put that rock?
Thanks, Joan. Just looking at an inset map of this Cape York area. This is this far northern part of the Great Barrier Reef. So the view there is the reef that we're on at the moment. This is this newly discovered 500 metre tall reef. It's called a detached reef because it's unusual in that it's not sitting on the Great Barrier Reef shelf itself, but detached. And there's 7 known detached reefs. They include the southern and northern small detached reef. You can see that one that's marked on the chart. That's about 2.5 kilometres just south of where we are now. Then we have some quite spectacular other detached reefs. There's the Great Detached Reef, very large reef. We have Saunders Reef and Yule Detached Reef, Woody Reef, and the very, very famous Raine Island. Raine Island sits on its own reef. It's a detached reef itself. Raine Island is known as the Galapagos of the Great Barrier Reef. And we passed it the other day when we were heading up to Torres Strait and back. But Raine Island is famous because it's the world's largest green sea turtle rookery. And in summertime, in about a month or so time, there will be thousands of turtles, green turtles, migrating from all over the ocean to this one small island. So Raine Island is about 60 kilometres or so due north of us. And it's just a very, very special part of the Great Barrier Reef. It's the very far northern area. Obviously, lots of mysteries. You know, here we are finding a whole new 500 metre tall reef. But for me, it's been a goal to get up here for many, many years. Really, it's just such a huge opportunity to come here on the Falkor and do really systematic mapping, and also have the ROV SuBastian come down and have a look and see what's living in these deeper waters of the far northern Great Barrier Reef. And yes, there's lots of crocodiles, mainly west of us, sort of closer to the mainland, but yeah, it's croc heaven up here. But I tell you what, I don't know if that would stop me from swimming yesterday if I had the opportunity.
Ah, for sure. God, that water was so beautiful yesterday.
Yeah, so it was like a swimming pool. We were just off the edge of the reef mapping, and you could have dived over the side and swum over to the shallow reef, and beautiful colours. But of course, it's still amazing to be down in these depths. Here we are, 1/2 kilometre down. We're at the very base of this newly discovered 500 metre tall reef. What's interesting is how quickly we've got into the hard rock limestone.
Yeah. So
I thought it'd be just like a scree slope at the base, just soft sediment all the way up. But we only got that really at the very beginning of the dive, and then we're onto this hard rock straight away.
Yeah, and I guess what we don't know is on previous dives, for example, the Tideman Knoll, where it was soft sediment on the flanks at the base, but we don't know how thick that sediment was. It might have been 1/2 metre thick, or it might have been 10 metres thick, and it may have had this hard substrate underneath it. But of course, we don't know, depending on how thick the sediment veneer is.
Yeah, that's right. We can only make those sort of guesses. But here now, we're clearly seeing a hard limestone environment with a veneer of soft sediment over the top. I wonder if this is one of these zoanthid colonised coral colonies. You know, where they take over the branches?
Yep, beyond the realms of my expertise, that's
Yeah,
for sure. So I wouldn't even like to hazard a guess.
We've seen some very weird looking coral colonies, and I think it was Jamie from Japan, who's a zoanthid expert. He picked up that it was a dead coral colony, but coated with zoanthids, and that might be what we're seeing here.
Just seeing if anyone on the YouTube chat can
Yeah, Jamie
us.
Reimer, that's right. Thanks, Dougal. Yeah, Jamie's one of our colleagues or colleague of Dougal.
Oh yeah, sea carrot. But it's moving, so it's got a hermit crab. That's another scaphopod, hermit crab.
Yeah.
Another scaphopod.
Good size one too. So scaphopod's a tusk shell.
Do you want the orange box? Yep.
There's something else. One.
Orange one. File box. Do you want us to say file box or put one?
Yeah,
in your
fire
log?
box. Yeah.
So,
Oh, wherever you want to put it is fine. It can go in with the rocks.
Do you think it fits the small one or two fits only the back size?
You want the whole thing or just going for a little piece?
So right hand.
We're going to sample this orange, whatever it is.
That's right.
Just talking about where we're going to put it in Sebastian, kitted out with a few different boxes and compartments and coral quivers and things. So just a bit of discussion going on about
You want to put it in the quiver?
no, going on about where, once we collect it, where are we putting it?
Is it going to be floating? If it's floating, we're going to put it in the quiver.
Okay.
Is it? Do you know if it's floating?
Is this floaty? I'm not sure.
I don't know.
Yeah.
Okay. We'll see once we grab it.
Yeah.
You just want half of it, you know, the whole thing? No?
Is it easy just to grab the whole thing? Then we can just grab from the. Yeah.
So we've got two ways of sampling sampling the biology. We're working with various institutes to flash freeze some of the biology in a quiver, which is just basically a tall cylinder, and we've got liquid nitrogen on board to fully preserve the DNA. And the idea is that once back on shore, these samples will have full genome sequence conducted on the living animal and any symbionts or animals that are living on them. So this colony in front of us is a good example of how we can actually look at the full DNA of all of the marine life, including the animals that are sitting on it, and it goes to understanding how these animals have co-evolved together. The other marine life, which just goes into bioboxes, are preserved just in ethanol, which is good for preserving the skeleton, the skeletal material, but not necessarily the DNA.
Yeah. Can we There's no polyp, but we still just.
Yep, pretty weird. I'd put my money on some kind of zoanthid colonisation there, Marty.
Going to 3 or 4.
So this is bio box 1, obviously.
Which is biobox 4.
Yeah.
There's a question coming from YouTube about are they Japanese characters on the boxes? So they're Chinese characters, and it's a message from one of our scientists on board, Joan Lee. It's her mum's birthday today. So Joan's wished her mum a happy birthday on ROV SuBastian.
Good. 2, we're at 2 quarters. A and B. Some parts of it. Just put this in there. And then, get everything to now.
So just doing a RV team handover, J-Rod's on the controls with Chris, assisted by Jamie on the wirecast. Yeah, thanks, J-Rod. All right, we're really only at the start of the dive. We've got 500 vertical meters to go, and we've got about 1 kilometre to go horizontally, so it's a distance to run today. And we're only at the very base of this 500 metre tall reef. Already we're into hard rock limestone, which is interesting. I didn't expect that.
Yeah.
Like we've left most of the sea cucumbers and those soft sediment animals behind. We've got lots of opportunities here, lots of little ridges where these perhaps older reef strata are exposed with small coral colonies and things attached to the side. And we're seeing lots of echinoderms, these urchins, haven't we?
So this hard limestone substrate base is potentially the foundations of the Great Barrier Reef at 560 metres.
Yeah, well, it depends how far down you want to go. I mean, the foundation of Great Barrier Reef can go all the way back to continental rock if you dig down deep enough.
The reef part of the Great Barrier Reef.
Yeah, that's right. So, you know, if you were to take a slice right through the edge of the Australian continent, you'll hit this hard crystalline basement, and that would be perhaps several kilometres underneath. But what we've mapped here is this really interesting big limestone ledge, isn't it?
Yes.
Between around about 300 to 600 metres depth. Think of it like a patio or a veranda that kind of sticks out, and it's fairly broad. It's about 10, 15 kilometres wide in places, and these detached reefs have grown upon this ledge. Now we know they haven't grown from this depth, so what's happened is the ledge would have been shallower in the long geological past and has subsided. But these reefs, the shallow portion of them, continue to grow as the ledge got deeper in the water. And I was trying to think of an analogy last night, and I think if you had think of a kitchen table and you put a plate on it, and the plate is the living shallow coral growth, and then someone chops off a few centimetres of the legs, so the kitchen table gets a bit lower, but you throw
stack another plate
on it.
Yeah.
Relatively, the top of that plate stays in the same position, but and you take another little slice off the legs of the kitchen table, it gets a bit lower. Put another plate on. This is what's happened with the reef.
It's a great analogy.
Yeah. So the living portion of the reef has always been in the shallower waters, but the ledge or the kitchen table upon which it's grown just gets lower and lower. And so now we have a kitchen table that's around, 300 to 600 metres deep, but we have coral reef that have stacked those plates one on top of another, still shallow enough that they've got shallow coral reef at the top. And that's how we get 500 metre tall reef.
And then you could extend that analogy to try and explain keep up, catch up, and
we've
give
got a
up.
bobtail squid. Or a cuttlefish. It's a cuttlefish.
It's a cuttlefish, yeah.
Yeah. So the cuttlefish, they're a cephalopod. You can see the broader, what do they call it? It's not a shell. It's the internal, cuttlefish bone.
Yeah. It's not called a rostrum, is it?
Well, we see them washed up on beaches all over all over.
It's what
the
you feed your
tropics.
budgie.
Yeah, feed your budgie, go with it. This is pretty small. Gerald, can you just put the lasers on briefly to just so we can get a sense of scale here? Lovely eyes. Okay, we've zoomed in here, but when you see the lasers, they're 10 centimetres across. So this is pretty small, probably 5 centimetres or less. Yeah, classic. This is a typical cuttlefish. There we go. There's your laser beams. They're 10 centimetres, so this is just under 10 centimetres wide. Look at that lovely, that iridescence that you get with these cephalopods. Just stabilising the ROV here. Yeah. So when I go scuba diving on the Great Barrier Reef, we often come across these giant cuttlefish.
Do you?
Yeah,
I
now
always
they're-
imagined that they were in cold water.
Yeah, well,
like
they
down
are the
south.
classic in South Australia. These giant cuttlefish. So I say giant in the sense that they're very big.
Yeah.
You know, they'd be 50 centimeters long
Oh,
easily.
wow.
And when I last went diving on the reef earlier this year with my 12-year-old son, because he got his scuba ticket for the first time, we were diving every day with these really large cuttlefish. And if you just swim up to them really slowly, don't make lots of arm movement, they will sit there. They will look at you, but usually stay right next to you. So we got within a few meters of them, and they start flashing different colors
Yep.
and tiger stripes and all kinds of things.
What a fantastic experience for your first introductory scuba dives.
Yeah.
I bet your son's hooked now.
Yeah. Can't wait. When we get back, it's summertime here in Australia, and we'll go diving again. So I'm quite a keen scuba diver, but yeah, my son turned 12, and he said, I want to learn to scuba dive. So we got him signed up for one of those junior paddy
Yeah, paddy
kind of
junior,
open water dive. And we did a liverboard. So while he was doing his ticket, I went out with him, and as soon as he got his ticket, after 1 or 2 days at sea, I just took him diving.
Wonderful.
Yeah, and like I say, we saw lots of giant isopod. This is Bathynomus scooting off. I like these.
Real quick.
Yeah, like a giant pill bug. Oh, there he goes. Yeah. And they live his classic. J-Rod's trying to chase after him really quick. They leave these classic holes on the seafloor. It's still scooting along, just over on the left
Interesting,
here.
because we see the isopod burrows where we've got that thick sediment package, that soft sediment package, but our substrate here is a bit harder. So here we go. There's a bit more.
Yeah,
sediment.
slowing down. Some of these big holes that we're going over could in fact just be the burrows of the giant isopods. This is a small one. We've seen really big ones on some of these dives. Yeah, this is only 10 centimeters.
This is the first one we've seen this mobile, isn't it?
Yeah. Usually they're pretty quiet on the seafloor, but gee, they leave these classic holes everywhere that we often see, and other animals use them as burrows. We've seen crayfish and other lobsters and things like that. A shrimp using fish. There's a fairly big shrimp going over there, dinner-sized shrimp. Yeah, boy, this is really active.
It's a mantis shrimp.
No, just another
just
big shrimp. There we go. Slowing down. Good chasing, guys.
Wow.
Hey, got J-Rod on the control. And off we go again. All right, some more boulders. That's pretty good. I do like the isopods because they're so weird.
They look so prehistoric, don't they?
Yeah,
And I
really
guess they-
prehistoric. Like something you can dig out of the Cambrian. You know,
yeah, they
the
look
sort
like
of old
trilobites.
Trilobites, yeah. And there's some sea cucumbers to keep Joan happy. We've got our scanning sonar in front of us too, which is starting to show up a bit more these harder sort of isolated boulders. So, as we go upslope, we're bound to see, the remains of boulders that have tumbled down through, a long time and just sitting here preserved on the seafloor.
Yeah. Can extend that to your table and plate analogy too. From time to time, some of the plates fall off the table and smash down below.
Yeah, bits break, tumble off. Okay, there's a good looking sea cucumber there.
Yeah.
This looks more like your deep water sea cucumber with all the...
This also looks like a Cambrian prehistoric.
Yeah, so if
Decoration.
you... and it's got a little commensal shrimp or crab sitting on it.
Yeah.
Just sitting on
Crab.
top. So if anyone's studied, deep geological geology, they would know about the fauna. Just trying to think the fauna out of out of Canada, where
the Burgess
the
Shale.
Burgess Shale fauna, which if you were to kind of solidify that animal and put it in the Burgess Shale fauna, that's kind of what you're seeing.
Yeah.
These probably more crustacean-like, you know, sort of elongate trilobites, but lots of appendages, and
I'm thinking Kimberella, I think is the one I'm thinking of.
so maybe people are sure, some of our experts
Some
are
weird
sure,
and wonderful.
can make the link between the Burgess Shale fauna and some of the weird critters that we see down here.
Waxiwa. Thank you, our armchair experts at home. Eve Seth, thanks very much.
Ooh, Marty, this is ulva. This is a green algae.
yeah.
Only grows in shallow waters.
Sea lettuce, that is a shallow water.
Sea lettuce, right? This is not a deep water algae. It photosynthesizes, so it must have drifted down from higher up in the water column.
So that is giving us a hint as to what we might see on the top of this
Yeah,
reef.
yeah. Big question. Are we going to see living shallow water coral, zooxanthellate coral, or are we just going to see, I don't know, a desert? Who knows?
It's wrapped
But yeah.
around a piece of coral.
Yeah, so this is ulva. It's a sea lettuce is another name for it. It photosynthesizes. It clearly doesn't grow down here. It's drifted
Looks pretty
down
fresh.
from the shallow water it's above.
It's very fresh.
The shallowest depth we measured at the top of this 500-meter cliff or reef is 40 meters.
There was a bit of a sweepstake going on in the bridge, wasn't it, when we were mapping over it? How shallow was it going to be?
Who's going to win?
Oh, here's one of those
A
giant anemones.
Big anemone, yeah, good size. So that's a good 20 centimeters across. You can see the laser beams, they're 10 centimeters wide. Oh, that's probably about 25 centimeters
Yeah.
across. And a nice shrimp sitting behind it. Oh, see, that's probably the wash from the ROV. It's just folding in a bit. Your classic, if you were to textbook style Nidaria with its base and tentacles, an anemone is it. That's your classic shape, isn't it?
Yep, pretty much.
Nidarian
It's
shape.
a mouth and a stomach, and that's about it.
Yeah, with some stinging tentacles.
Yeah. I'm sure that my colleagues would argue that there's very much more to them than that.
Ooh,
That's a
black
very
coral.
simplified explanation.
There's a black
Yeah.
coral here.
Yep.
Just waiting for the sediment to clear. Plenty of shrimp. Look at all the shrimp in the holes here. There's a lot going on in that rock. It's definitely a shrimp party, but we got brittle stars. The white colonies are stellastrid hydrocorals. Right, Jeremy's in. Morning, Jeremy.
Morning, Jeremy. Just having a chuckle at your typo on our Slack. Just let this sediment clear, and we'll focus back down on that rock we were looking at just a moment ago, where we saw a black coral on there. Jeremy's multitasking in the lab today, extracting DNA while watching the live stream. It's dedication. Good on you, Jeremy.
So we're just letting the sediment clear here, and we'll have a closer look. It's our first black coral. No, we saw that spiral black coral earlier, didn't we? We've all become black coral fans here. They were initially hard to identify, but now with Jeremy's excellent audio and descriptions, it's actually pretty easy to spot them now. So the inset view is showing the mapping that we've done over the last few weeks. this new 500 metre, newly discovered 500 metre reef is right in the middle, centre there. The bump just to the south of it is northern small detached reef. So this is well charted from the late 1890s. So, you know, in the days of sail, the very early exploration of the Great Barrier Reef was done by lead line, and these detached reefs, these tall detached reefs, were quite well marked on charts even back in the late 1890s. So this newly discovered 500 metre tall reef is the first 500 metre tall reef to be discovered in the Great Barrier Reef in at least 120 years. So it's quite significant. And its presence is here on this very deep ledge, this 300 to 600 metre deep ledge. It's it's at least 10 kilometres wide in places. The actual Great Barrier Reef, the barrier reefs themselves, are about 6 kilometres due west of where we are at the moment. So you can see that was the nautical chart, and it's just with a bit of transparency there to show that it hadn't been discovered before. All right, so we're getting a clearer look now at this black coral. There's plenty of marine life on it, lots of little, there's some shrimp. I can see 3 shrimp straight up. Little squat lobsters, yeah. So we're just talking, we're just communicating with our other principal investigators ashore, including Jeremy Horowitz, who's working in the lab at Townsville in northern Queensland. Jeremy wasn't able to join us on this leg on board, but he's certainly done his time at sea. Jeremy and I were first on the Investigator last year. We spent a month out in the far eastern side of the deep coral sea within Australia's Coral Sea Marine Park last year, and he was on the last Falkor voyage, which was seamounts, canyons, and reefs of the Coral Sea. Of course, everyone's been quite affected by the whole COVID crisis. With state borders closed around Australia, we could only get a Queenslander team on board for this latest expedition. But we have quite a big group of principal investigators all around Australia and even overseas. And of course, we're all able to communicate in real time. We're using Slack so we can get real time updates from each other about, you know, decisions on whether we sample or not. So Jeremy's saying this is a heteropathes or a hexapathes.
Can be called as heteropathes.
Heteropathes. Mm-hmm. The shrimp are coming in to check out what we're up to. They won't. Oh. They won't want to get too close. Very delicate operation. So from the camera angle, it's really difficult for Chris on the manipulators to see exactly where the stem of this coral is so that we can pick it up. So not only to see it, but then also coordinate the movement of the arm. And there we go. We'll securely stow this into the quiver, get the lid put on. Which again is no easy task. There we go. Thankfully not a lot of current today. You can imagine how tricky that would be if we had a bit of current flowing as well. There we go. Very nice. So we have 10 different cameras on ROV SuBastian. The ROV pilots can get a view, situational view all around, in front, behind, above, and they use all of that vision, all of those cameras to keep an eye on where SuBastian is, and as you saw there when we're doing the sample collection, sometimes it's easier to look in the situational camera from the top-down viewpoint to see exactly where they are and what they're doing. Yeah. All right. Continue on our way. So we're at 530 meters depth now. We're still really at the very base of this reef. We're making our way towards the or along the side flanks. It's a little eel. What is that? Just scoot back and check this little guy out. What have we got here? Fish people. Oh,
Yeah, is that
Just
one of
one of
these
those little eels
these
again.
eel, like snake eels fish that we were so intrigued with?
we've seen a couple of these on the previous dive.
Yeah.
haven't we?
We got a good look at it too, didn't we? So there's another good view, I think.
This one looks a
But
bit lighter in colour, the other ones are a bit darker.
yeah, there's a bit more sort of patterning on the side, but the head looks very similar. Very quite flat looking head.
There's a little bit of a delay between what we see here in the control room and what you see on YouTube. So we just wait for our fish people to catch up.
Yeah.
Will's looking for reinforcements from John.
That's right. I'm sure even in the fish game, there's everyone's a specialist in one thing or another. So we've got
Yeah.
John
It's
Pognoski.
like when you see a rock and people say, "What rock is that?" And you're like, "Oh God, I have no idea." Must be the same for the fish
Is it
people.
a soft rock or a hard rock?
What fish is that? Oh,
So,
who knows?
so geologists, you say you're a soft rock geologist
Yeah.
or you're a hard rock geologist. They're quite distinct. Oh, here we go. John's on.
Snake eel. Shame we can't collect it. No.
Colopsis
unfortunately, we
or
can't
snake
collect
eel? No, unfortunately, yeah, we don't have permits
snake eel.
for fish, unfortunately. So we're going to have to.
it. World leader on eel tax. Also, John is the world expert on eel taxonomy.
Great.
So we have all the expertise right there. So we can't collect it, so we will get some good vision here.
Okay, so people are seeing things on the
Oh, no,
top.
it's back.
And we're not really noticing that. Yeah, we get slightly clearer view here in the control room. We're getting a 4K vision. In fact, the whole walls, the entire wall of the control room is just, well, it's 30 large flat screens. So it's,
Yeah, looks like NASA controlling
yeah,
here, doesn't
it does. It feels like it.
I don't know anything about these critters or their behaviour or where they live or anything, but often eels, they're in their hole or their burrow often, aren't they? You just kind of see the head part or the top
part,
half
yeah.
sticking out, but every time we've seen one of these guys, we've seen the whole thing.
Yeah. Yes, these are different to moray eels. They're the ones that I'm more familiar with in this really shallow water environment. The warmer tropical waters. You can get some quite large moray eels, and they have very different looking head to these. The biggest moray eel I've seen was around 35 kilograms.
Whoa, what?
Yeah, yeah. It was captured because it was posing a danger to tourists at Cod
my
Hole
gosh.
at the Northern Ribbon Reefs.
I can imagine what the size of the head must have been.
It was like the size of a soccer ball.
Wow.
Yeah,
Wow.
yeah. And in fact, it actually attacked a scuba diver.
I was going to say they would just about swallow a small child.
Yeah, I don't think it was a complete accident. I think it was not deliberate. It was just
Yeah.
the scuba diver,
Yeah.
we understand, had some food in the buoyancy vest of the diving gear, and it was really aggressive about trying to get the food out. And
Yeah.
yeah. Yes, Will. That's right. I think we'll continue on. Thanks, J-Rod. We're really at the start of the dive. You did say, Marty, you're
Keep
gonna
you on
remind me.
task. Let's keep going.
We have 500 meters to climb,
Is that just a soft coral beside it there?
and we're only at the base, really.
Yeah.
So I described earlier that what we're looking at is something a bit like one of those. This looks like a baler shell. No, it's a urchin.
Urchin.
Yeah, we got a cucumber behind it. So it looks like one of these American boots.
Yep.
I got it right.
Butte.
As you find in the American desert, very a broad base with a very very steep wall up to a flat top. There we go. Yes, inset view of this is the area we've been mapping over the last 3 weeks. So place cool. It's in the far northern Great Barrier Reef. It's just offshore of Cape York Peninsula. So Cape York Peninsula
Just
is.
describe what map that is. That's the
Yeah,
chart, isn't it?
yeah. This is the
navigation
nautical
chart.
chart that's been made translucent. So you can see the northern small detached reef, and that's the modern nautical chart. These reefs, these detached reefs, were mapped in the late 1800s.
That's a great demonstration there of how the new reef that we're diving on is not on the nautical chart.
That's right, yeah. And so here we have, it's a new discovery. It's not every day you find a 500-metre tall reef on the Great Barrier Reef. Ooh, this is interesting, Marty. What have we got here? Is this like a framework coral?
Yeah, this definitely looks like coral framework. I guess what we don't know is whether or not this is in situ, part of that sort of basement reef substrate, or whether this is a block from somewhere else. It's fallen down here.
Yeah, it definitely has that eroded.
Look at all those nooks and crannies and
Oh yeah,
crevices,
shrimp
all that
party,
cryptic life.
shrimp party up here. There's quite a lot of action in here. Lots of brittle stars, lots of shrimp. Some little stylastrid hydrocorals, these really delicate white coral colonies.
I'm just going to zoom in on some of these corals and things here. I'm sure Jeremy's watching while he's working in the lab. Gosh,
Yeah.
every little crevice has a shrimp in it.
And there's a really nice anemone over on the
Yeah.
top left here. Worm snails. Gee, there's a lot of life on this rock.
Tip of the eyes on this one.
So when you scuba dive on the shallow coral reefs at night time, and you're shining your flashlight or torch around, it's often the shrimp eyes that you see. And because during the day they tend to be tucked away in nooks and crannies. It's not until night time do they really come out, and you really you realise just how many crustaceans and shrimp are actually on a coral reef. It's only at night time do you see them.
See the light reflecting from their eyes, shining from their eyes. That's what's fabulous about night diving, isn't it? I haven't done too many. I've only done, I don't know, maybe 3 or 4 night dives. But I love it. It's just a whole nother. I mean, scuba diving itself is a whole nother world, and then night diving is a whole nother world again.
Yeah,
where
that's
all you
right.
see is what's in the beam of your flashlight.
Yeah,
Torch.
and you get because it's that bright white light from your own artificial light, the corals tend to look even more colourful than they
Yes,
would
in
during daytime.
Yep. Yeah, it's ironic, isn't it? Sometimes you can see more on a night dive than what you would see normally.
Because that's been a feature of the SuBastian dives. We have this very bright white light. We're looking into the depths where it's completely pitch black, and in fact there is a lot of colour here. That's quite. I often get people asking, why is it so
Yeah,
colourful
why so much colour?
down there? And we don't have easy answers for these things. If it's completely black, why would you have brilliant colours? But one of the features of colour at depth, deep depths, there's often red coloration, isn't there? Like a lot of animals have this deep red colour,
Yes.
and we know that red is the part of the light spectrum that is most absorbed. It's absorbed more quickly in salt water.
Yeah. So I can understand being a critter that's red, because that would make you invisible.
Yeah, more invisible. Yeah. It's quite amazing, isn't it? Just this one little coral rock and becomes such a home for all this animal life.
Yeah. So we're looking at the sampling options on this rock at the moment. So just a little bit of conversation going on in the background about what we're going to sample, and again the discussion about where we're going to put it.
Oh, the shrimp a few of them are bailing out here.
Yeah.
A couple poking their heads up over the back.
They're real characters, aren't they?
Yeah.
You wonder what, anthropomorphizing here, but you wonder what's going on in their heads and what they're saying to each other. And,
Yeah. Could this rock just simply be a fragment that's rolled down, Marty?
Yeah, it certainly could be. Yeah, it does look like it could be in situ. But, you know, some of the blocks we've seen have been huge. They've been, you know, the size of a car, things, haven't they?
Yeah. That's right. And with like some of those canyons that we dived in earlier, even though the sidewalls are made of kind of a softer, well, turbidites actually, you know, it's layered finer sediments, they can break off as clumps and roll down slope. They look like
they
boulders.
Look like rocks,
Yeah,
boulders,
but
and
they're
then we
actually
use
soft.
our super technical technique of giving it a poke
Yeah.
and find out that it's a big slab of mud, consolidated mud.
Yeah. So we did that earlier in this dive, and we found that the seafloor here is actually pretty hard.
Yeah. Yep, the boop test.
Yeah.
The tried and tested boop test.
Yeah, that's right. Touch it, see
gives
what
us a lot
happens.
of information.
It does. It does. A very early dive out in the Coral Sea this year, we came across a wall of holes. It turned out these holes were isopod burrows, but at the time we didn't know what they were. It wasn't until we touched them, the whole thing was very, very fragile and broke away. But then it made perfect sense what we were looking at. That these were the burrows of isopods, and you know the holes were left preserved in this kind of stiff mud. Yeah, so just a simple touch test is often enough as scientists to try and make sense of what we're seeing here.
Looking at pieces.
So this is one of these flash frozen samples, isn't it, Marty?
Going into the quiver, and once we get the lid on, the other important factor is that the water temperature inside that quiver will stay constant or more constant throughout the dive once we get to the surface than if we had put it into a bio box where we're constantly opening the lid all the time and mixing up the water, because these samples that are going into these coral quivers are going to have their DNA sequenced for the genome.
Yeah, with the Sanger Foundation, is that right?
Institute, I think,
Institute, yeah, and so this is a collaborative project that Jeremy Horowitz is involved with, and we're helping out in this leg. So we had to transport liquid nitrogen up to Cairns to get it on board the ship. Interesting exercise in
Yeah.
itself.
And so yeah, the lower we can keep the temperature, so increasing the temperature starts to degrade the DNA. So
Yeah.
that's why we
So when we get back to
frozen.
Cairns later this week, on Fridays, at the end of leg 2, we have to unload many of these samples, including all of these flash frozen samples for transport back to Townsville.
Yep. not me. I'll be staying on board for leg 3.
Yeah, you never leave, Marty.
Yeah.
You got your own.
Getting a little bit too comfortable
Yeah.
here, I think. All my responsibilities at home will be still there waiting for me when I get back.
Yeah. Got someone looking after your pets and
Yeah, I've got my sons, hi Sean, hi Ryan, looking after the pets. Well, actually, the pets are more or less theirs. Looking after the dog, hopefully watering the plants, although Brisbane had a big thunderstorm yesterday, so we've had plenty of rain in Brisbane over the last 24 hours. So hopefully the plants are still alive, possibly turning into a jungle. Hopefully
Yes.
the weeds haven't taken over too much.
yeah.
I'm sure your son's doing a great job.
I'm sure they're doing a fantastic job.
Wonderful young man.
Yeah. With any luck, they might have started on some renovations by the time I get home. Just putting that out there.
Be lucky if they wash the dishes.
Oh, he escaped. Trying to grab him.
So they have their cousin has moved in with them, and their cousin is a apprentice carpenter. So hopefully there's every chance that some renovations might be underway.
I don't know. I'm thinking bachelor party, not renovations, Marty. I think you're going to be a bit
I think
disappointed
I'm being a bit
there.
hopeful.
Yeah.
Yeah.
Yeah, so this is a long voyage really. It's 47 days and it's broken into 3 legs. So we're really only at the end of leg 3.
Leg 2. End of
Oh, sorry,
leg
leg 2, that's right. We have one more leg and that will be from Cairns back to Brisbane, your hometown,
Yep.
there, Marty. But unfortunately, it's the end of it for the ROV SuBastian here. The ROV team is heading back home as soon as we get into Cairns. So today is the second last dive for ROV SuBastian in Australian waters this year.
Yeah, one more dive tomorrow. All going well.
Yeah.
And
And then that's it. It'll
Yeah.
be the SuBastian will be packed up, and everyone's getting ready for a big crew changeover back in Cairns.
so leg 3 on our way back down to Brisbane. We're going to head to the southern Great Barrier Reef, back into the Swains Reef area where we sort of started on leg 2, and do a little bit more mapping in there of some shelf edge features that, again, similar to up here, that have not really previously been mapped, not with any sort of systematic survey anyway. And then we're going to head a little bit eastward towards the Tasmantid seamounts. And we'll be mapping around the Tasmantid seamounts.
Out in the Coral Sea Marine Park. So we'll be we're leaving the Great Barrier Reef Marine Park behind and heading further out east into Australia's Coral Sea Marine Park and mapping around some extinct volcanoes. They're called the Tasmantid seamounts, and they're if you're familiar with the Hawaiian chain of islands, those Hawaiian chain of islands are there because of a hot spot that's stationary as the plate that Hawaii is on moves very slowly over the top of that hot spot, and occasionally you get these volcanoes popping out, which are, there's a long trail of them, and the modern Big Island and Oahu and Kauai and all those other islands are just the remains of islands of volcanoes, some of them still active, like on the Big Island, that are above the surface. Above the surface of the sea. So in Australia we have a similar hotspot chain of extinct volcanoes called the Tasmantid seamounts, that as Australian plate broke off from Antarctica and is drifting northwards, there is a similar hotspot, and that those volcanoes have left a chain that run down the east coast of Australia. And if you look at Google Earth, you can see them very, very clearly. They look like giant mountains in the sea, and they're almost in a direct line. The oldest one is probably around 50 million years, and they kind of stretched down to 20, 30 million years ago when they stopped, erupting. Interestingly, though, the ones that are in the tropical waters have coral reefs over the top of them, and even islands. And so we are just in the middle of negotiations with the Parks Australia, which is the organisation that manages and looks after these these unique island habitats to go and visit them as part of our leg 3 voyage back to Brisbane. And at this stage we're looking at doing vegetation surveys and bird nesting surveys and things like that,
Yeah.
to assist Parks Australia, because they're so rarely visited. So the Falkor's leg 3 is an opportunity to do that.
Yeah, so they'll be photographic surveys. So we'll have hopefully we'll have our multimedia correspondent on board on leg 3 with camera equipment and a drone, and we'll be able, fingers crossed, depending on the conditions on the day, we'll be able to step onto these caves, these islands that are on top of these seamount reefs, and get some photographic imagery of the condition and any features of interest.
Yeah, and some sort of more practical, even practical things like looking to see if there's any like feral animals like rats or mice or even ants and things like that. Because there's such small habitats, often really important places for nesting seabirds, that if ants get on there for whatever reason, maybe visiting ships or even logs that have drifted across the oceans, then they can create havoc with the marine life that live there. So the Falkor is an opportunity, just a brief visit, a snapshot in time, to help the managers of these very unique habitats.
These are very, very highly protected islands, aren't they? It's not somewhere where you could go if you were going out in your boat.
No, not at all. I mean, we're talking hundreds and hundreds of kilometres way out to sea here. So going back to leg 3, once the Falkor departs Cairns, it'll head south into the Swain Reefs area, which is quite a remote part of the Great Barrier Reef. But having done some mapping there, it'll head further east out into the deeper coral sea waters. It's a crab. Yep, with some kind of lid on top. Just having a closer look. Is it a hermit crab or just something else there, Marty?
Decorator.
Decorator crab?
Crab wearing a shell hat.
Shell, yeah.
Not very impressive. We've
No.
seen far better decorated.
Yeah, we
ones than
have.
that.
Unless, let's have
Oh, is it
a...
a piece of shell?
Yeah, that one, where was it? It was the plunge pool dive when that...
I think it was on Tideman Knoll.
Tideman Knoll?
Parachuting decorated crab.
Parachuting decorated crab, and it had, was it big zoanthids?
Yeah,
on it
the
for
shell.
hat?
So
Yeah.
the crab was holding a shell that had zoanthids on it.
And then it leapt off into deep water and drifted there in full view. I was gobsmacked. It was probably the most funniest, amazing animal I have seen
We were
on this
waiting for
voyage.
this thing to come to grief, weren't we? But no,
Yeah.
it was like a parachute, very gracefully drifting down. Had it totally under control.
Yeah. No, I was just gobsmacked at that one. That is the weirdest animal,
Yeah,
or
that was fun.
animal combination I've seen yet.
Here we go, just manoeuvring.
It's a good
Sebastian
size
around
though.
to the other side.
It's 10 centimetres, 15 centimetres across.
Is it a piece of sponge? I think it's sponge.
Yeah, it looks like it's... Yeah, but how's it staying on there? Like, what's holding it? Is it using a leg?
Yeah. Yes, you see that now. It's using one of its legs to hold on to the
Yeah.
sponge. It must be exhausting holding on to that all the time.
Yeah, okay. So they use their back legs. That's interesting. Yeah, you can see how it's folded in underneath.
Yeah.
So here's a question, can they release it? Or is it like locked on? Like, can they shake off the sponge or an enemy?
I guess so. I mean,
Question
Yeah.
for our experts ashore. So these decorated crabs, can they just cast off whatever they're using as a
if
decorator?
I was a decorated crab, I'd be looking around for the fanciest thing I could find. So then if I found something fancier, I'd be wanting to get rid of the
Yeah,
previous thing and collect the new thing.
I see. You're like the ladies at the sweepstake. Your fascinator's better than mine. I'm gonna...
there's a suggestion that the sponge is an offering to the megaclaw.
Yeah. Okay, we're getting some flat sea cucumbers here. Off we go. It's like mountain climbing today. We're at the very base of it, and we're just slowly climbing up this relatively gentle base. The base itself of the new reef is around 1.5 kilometers across, just to put that into perspective. And then when it goes vertical, it's like the surface area just gets smaller and smaller. The top of this reef is around about 300 meters long and 50 meters wide. So it's all coming up to a bit of a point. And the top of it's around about 40 meters depth. Ooh, there's a cowrie shell just up here, I think.
The Guardian.
So we're just having we're just focusing in on this colony, and all the time we're reaching out to our colleagues ashore just to see whether it's worth sampling or not. Little brittle star wrapped around the main stem.
Polyps, don't we? And we do a tentacle count first to see whether it's 8 tentacles. Which
8
would
or
tell us
6.
It's an octocoral.
Yeah.
Coral.
Yeah, there's a cowrie, and it's just
It's a good
dead.
size one too.
Yeah, typically in shallow water, so this would have rolled down from the summit.
Looks like it's been there for a while.
Yeah.
Oh, look at the cat worm there to the right.
It's like a little... Oh, what's that?
It's a foram.
Oh. Beautiful. All right, so test. Is it a benthic foram or a planktonic foram?
That is a benthic foram for sure. Yep.
Okay, that's...
Benthic. First giveaway is that it's on the seafloor. No. To my mind, the planktic forams, well, for the most part, they're really tiny, very small. We call them, well, microfossils, or even nanofossils, depending on how tiny they get. And to me, their test looks bubbly, which makes sense. Being planktic, you want to be capturing air so that you're kind of floating in the water column. So the planktic forams, I mean, I don't work on forams, let alone planktic forams, but I've seen a few. And to me, they look like little bubbles, like little, you know, when you're blowing bubbles with your detergent.
Yeah.
They have a chambered test, like all forams do. And so lots of these little bubbles. Oh, that's a block of coral. That's a coral colony.
Oh, it is too.
Yeah.
Yeah, you can see the corallites inside. So this could have rolled down
Yeah,
from higher
yeah,
up.
I would say for sure, yeah.
Yeah. Yep, so we can't say this is in situ. It's very likely a boulder, and you know, we're in cyclone country here, and could easily have rolled down slope. There's, in fact, the last cyclone that came through here was March last year. It was, I think, a Cat 2 went through Lockhart River. Lockhart River is the closest community to where we are. It's around about 60 kilometres due west. It's an Aboriginal community. It's a small town, and in a place, Cape York, where there aren't that many towns at all. But they actually got hit quite bad. This is Bryozoan.
Bryozoan, it's beautiful.
Yeah. And some polychaetes with their tentacle, what do you call them?
What are they? Palps.
Palps.
Thank you, Becky.
And these interesting slime tubes, they sort of
Talked about
coil-like.
these a bit, haven't we? I don't know that we've really
Yeah, well, we reached out to Will and John to ask whether these basket eels are making these kind of slime baskets. Because I have seen eels, cutthroat eels, inside them,
Yeah.
almost like a sleeping bag
Yeah.
hung off a rock.
So, don't parrotfish do that too when they're
Yeah.
sleeping? They create a little mucus
Sleeping bag,
net,
yeah.
basket, whatever.
Yeah, when they're sleeping during at night time, the shallow water parrotfish can make this mucus bag, and the thinking is that it stops the odour or smell of the fish drifting beyond where they're sleeping, so that predators like, I don't know, sharks and things don't smell where they are and hunt them out. All right, we'll continue on. We still are only at the
Still
beginning.
only at 500 metres.
We got 500. We're in mountain climbing mode today, so we're only at the base, climbing up. Yeah, we haven't even cracked 500 metres yet. So we've got to continue onwards and upwards. Yeah, John's asking, like, see a picture of those basket work eels in the slime bag, in these slime bags. There we go. Big urchin just having a bit of a crawl. Yeah. Lots of urchins on the seafloor, eh? Aren't they? We've seen the dead tests, we've seen living ones. This seems to be a real feature. Lots of rubble, including the shallow coral colony we've just seen then. But whenever we see this dark coloration, this has been here a long time.
Yeah, I was just going to say that boulder that we just saw before, where we were talking about it being a coral, a massive coral, basically, that looked like much fresher and younger.
Yeah, yeah.
This looks much older.
So interesting sponge action on the left here. That translucent sponge. This is a siliceous sponge, a hexactinellid. Oh, it's got a. It's another decorated crab. It just moved. Yeah. Yeah. There's a crab under that. Again with a fascinator. It's another coral colony. I can see the coral lights. Do you see behind it?
Yes, you can. Yeah.
Yeah. So this has been here for a while. There we go. It's fish for John and Will. But there's quite a large rock sponge just above here. That's this. It looks a bit like a fungus that's attached to the rock. A fungus that you'd see on a dead tree. But
Yeah, when you're going for a hike in a rainforest,
Yeah.
to see those. I can't think what the name of them is. They look like a horse's hoof stuck
Yeah.
on the side of the tree.
yeah. So that they're on the top right. So it's pretty sure it's a rock sponge. And when they have a very dense siliceous skeleton, when you break them off, they feel heavy. But what you're feeling in measuring is actually mostly water. So when they dry out, then they become really light. But I remember the first time we sampled some of these out in the deep coral sea with Jeremy Horowitz, and it looked like bone. And it wasn't until it dried out then you could see that it's just really a dense sponge. This big pile of gravel here. Up we go. We got our situation camera as an inset, because the SuBastian's got 10 cameras, I think, all over it. So we've got a lot of screens here giving us a full 360-degree picture of what's around us. The situation camera just is a wider perspective. It's not as high resolution, but we can see what's happening ahead of us.
The other day, while we were looking intently at the forward-facing science camera, we had a couple of sharks swimming around behind us in the rear camera.
Yeah, and we got to look at them too, didn't we? They were silver tips.
Yeah, that's right.
Yeah.
I think
Very,
pretty good size.
yeah,
One of them was
yeah,
probably
yeah.
about 10
Very
meters.
sharky looking shark.
Yeah,
Was quite interested in this.
it just goes to show that you've always got to be looking behind you.
Yeah, and this is, in fact, it's interesting you mentioned sharks. Just here where we are is these detached reefs. Raine Island is one of these really well known. Oh, there's a flat fish, flounder.
One of these flounder.
Let's have a closer look at this.
I've seen a few of these now too.
Yeah, there's a good look. Okay. So is this a
The other ones we've seen
right-eyed?
have been much more docile than this one.
Yeah, yeah. Right-eyed or left-eyed? Problem, it may have just dived into the sand here, Marty. I mean, they can often do that, and all you see is just these little wiggly eyes sticking out, with the rest of the body completely buried. I think we may have lost them. Oh,
Says he
what's
thinks
it?
it might have been a right-eyed. That was very,
Right-eyed. Well
you were
spotted.
very quick, John, to
Yeah.
be able to spot that.
Yeah, so I was just saying in this area we have Raine Island, which is about 60 kilometres north of where we are, world's largest green turtle rookery. And in summertime, when all the turtles come in, it brings all the predators, and the main predator here is tiger sharks. So the tiger sharks feast on this huge turtle migration. You know, as turtles get old, they tire. They basically just get worn out and eventually die, and then the tiger sharks come in and have a feast. So
Very easy pickings for a tiger
it
shark.
really
isn't it?
is. Yeah, it really is. And my colleague Richard Fitzpatrick, who's a principal investigator on this voyage, has done many trips up to Raine Island to film this. Really spectacular kind of the ecology around it all. Where you have these just huge numbers of turtles coming in, and these tiger sharks very slowly, no frenzy going on here, just slowly swimming around and picking off the weak or dying turtles.
And then when the babies hatch, then all the seagulls and seabirds are there waiting for them.
Yeah, that's right. Yeah, he did a documentary some time back called Nature's War Zone, and it really comes across. Yeah, it's quite a challenge for all the baby turtles to survive through to adulthood, and it all starts really just at the beach.
Beautiful colouring. on this side.
So what do we got
Is
here?
this
This
a lizardfish?
looks like a lizardfish to me.
Big eyes. So I think the statistics are something like 1 in 1,000 turtle hatchlings grows to maturity and makes it back to breed.
Yeah, yeah. So there's a fair bit of effort going on in Raine Island at the moment. It's called the Raine Island Recovery Project. There's a lot of individuals and organisations and Aboriginal groups involved, but if you're interested in reading about it, you can go to the Great Barrier Reef Foundation website and read about the Raine Island Recovery Project. So that's all happening on this quite small island, Cay, sitting on top of a detached reef, just north of where we are at the moment.
We sailed past there, was it yesterday?
Yeah.
Yesterday we sailed.
Sail past it.
Past, yeah.
And you can see there's a quite a distinct convict-built beacon that was built in 1844. It sits on it. It's because Raine Island Reef is one of the first reefs you see when you're coming in from the east, from the deeper coral sea from the east, and all those early travellers through the 1800s would often use Raine Island beacon as to navigate onto the Great Barrier Reef. This is before lighthouses existed here or anything like that.
It's quite an interesting feature, isn't it? You can look at sort of aerial photography and what have you over time, and to see the mobility of the sand on that cay. So the beacon isn't moving, but the sand around it is quite mobile
Yeah.
and moving. So when you compare images over time, you can see how much migration of the sand or erosion of the sand has occurred relative to that beacon.
Yeah, so this is part of the Raine Island Recovery Project to try and understand that dynamic change on the island. So I got involved because Richard collected a whole lot of drone imagery. Here we go, it's just the inset shows Raine Island. This is just north of where we are at the moment, just a couple of hours sail for us. And we mapped along the eastern side of it yesterday morning as we're coming back from Torres Strait. The island itself is not very long, it's about 600 metres long and only 200 metres wide. But this is the world's largest green sea turtle rookery. And what I was saying was Richard used his drone to photograph the island, and we did photogrammetry and did a full ortho mosaic and digital elevation model of the island. And so now repeated drone flights are flown every few months to capture that same island area, and then we can compare the images, you know, the temporal change of the island to get a sense of, you know, where the turtles are nesting and how the island is changing through normal seasonal changes.
Yeah, that erosion of the sand, and I guess we're starting to experience sea level rise too, is a natural phenomena. But for the turtles, because this is such a significant turtle rookery, once the sand all goes, that's it for the turtle.
That's
turtle
right.
Rookery.
Yeah. So they're on this very thin edge of sand around the outside of this of the cay, of the vegetated part of the cay. So there's it's a pretty important site. I think David Attenborough described it as one of the most amazing animal migrations on the planet, with the turtle migration to Raine Island. So we're 462 meters depth. We're climbing up the gently sloping base of this newly discovered 500 meter tall reef. It's getting much more rubbly, isn't it there, Marty?
Yes.
We're seeing shallow water coral pieces, like these bits of coral. Yeah, I'm definitely seeing shallow water coral here.
This is very typical of reef slopes everywhere, isn't it? Where you get that fore reef debris
like
accumulating at the bottom.
Yeah, big
It all has to go
scree
somewhere.
slope.
Yeah.
Yeah. Oh, another Nautilus? Is that? No, it's a urchin. They've got about the same sort of round shape. Sorry, I'm a bit psyched up for a Nautilus. Everything's a Nautilus. So there's a good question from Liz. Can you reshape the beach? And in fact, that's part of what the Raine Island Recovery Project is about. So the Queensland government have, and I think BHP is one of the big contributors to the funding. It started with a small study site to reshape the beach, not adding more sand, but literally just shaping it so it was a bit more conducive to turtle nesting. And they also fenced off some rocky areas on the island itself, because the turtles were being trapped in the holes. They couldn't make their way back onto the beach. So there's been a fair bit of effort to try and make the island a bit more turtle friendly, and that's been very successful. So so a colleague of mine, Andy Dunstan, is really involved in that. You may have heard me mention Andy before. He's actually a Nautilus expert. I know as much as I know about Nautilus just from the work that Andy Dunstan did, but he's now working with the Queensland government as a ranger and spends a lot of time up in the Raine Island area. And so he's involved with this project where they actually reshape the beach and just give it a little bit more slope to allow the turtles to nest. And the success rate for the turtle hatching is definitely improved with this reshaping of the beach. But of course, in doing that, you have to understand what the natural variation of the sandy beach is itself, and hence that's how I got involved, where we were doing this photogrammetry using drone imagery over Raine Island itself. All right, so continuing to go up, got Chris and J-Rod on controls, helped by James on Wirecast, and we're just taking turn about here to have lunch because it's coming at lunchtime here in the Falkor. So very rubbly, and we've also seen this kind of bulldozed trails. Now, in the past, these have been made by urchins. So urchins, like they just bulldozing through the sand. We've seen lots of these, the tests, the dead remains. So I'm putting my money on urchins making these big long zigzag trails across the seafloor. So we're going through a bit of a thermocline change here, and this is really common in all of our dives that are below this 500 meter mark. When you get to around 450 meters, the thermocline really starts kicking in. So we're up to 10.5 degrees C, still pretty cool, but from here on, we're getting into these warmer surface waters. So that means kind of lower mesophotic zone. For us, that's a real distinct marker between the cold water coral environment deeper than the 450 meters, and everything above is going to be just mesophotic kind of coral life. We'll get high enough today, right up into the shallow photic zone. Fingers crossed, we're going to see some living coral, living shallow water corals up on the crest of this new reef. So we'll see what we find when we get there. So we'll continue heading up through the day. It's about a 7-hour dive for us. That's what we have planned. So perhaps around 4 o'clock in the afternoon, we'll recover the ROV back on board. And I mentioned this is our second last ROV dive for this northern depths of the Great Barrier Reef. We have another dive tomorrow. We're going to make it steep and deep. We'll start with a Dougal dive through the midwater for about 3 hours, but we're going to push it down to around 2 kilometers deep tomorrow. So it'll be a really big, long, deep dive, 2 kilometers deep, and we're hoping to make it a great last dive. And then the ROV SuBastian will be packed up. Here we go, there's an inset showing us where we are. Not quite halfway up this steep reef. It does look really steep in that view. This is the 3D mapping that we've done over the past couple of weeks while we've been around here. So we're just climbing up this gentle gradient. It'll slowly get steeper and steeper as we get near the top. But already we're seeing coral pieces that have literally rolled down the slope into the deeper depths. The whole reef itself is on this big ledge that extends out from underneath the Great Barrier Reef. It's about 7 kilometers wide where we are here. So the Great Barrier Reef, the barrier reefs of the Great Barrier Reef are only about 6 kilometers due west of where we are. And all of this rugged seafloor terrain is what the Falkor has been mapping over the last few weeks. Really incredibly complex, far stranger, far more complex than anything we imagined. It's been an area I've been really interested in coming to for many years, and it's just been such an amazing mapping expedition. We're just going for a bit of a fly through along the edge. This has all been mapped just in the last few weeks. You can see these great big canyons draining from the edge of the Great Barrier Reef into the deeper waters, over 2 kilometers deep in places. Some of those canyons have heads that go right up into these interreef passages between reefs. That's Bligh Reef we're looking at there, named after William Bligh from Mutiny on the Bounty fame. He was cast into an open boat and had to sail thousands of kilometers to rescue himself and his crew members. And he sailed just in that passage at the just on the left-hand side of that kind of curved reef. So more of this bulldozed seafloor, bioturbation in the softer sediments that are draping around the base. Oh, here we go, another inset view. So we're continuing to kind of look, sort of fly southwards. If you're a Google Earth perspective, all that red and orange area, that's the shallow Great Barrier Reef. It's around the red areas you could scuba dive on. It's at sea level surface. The yellow areas are probably around 30-40 meters deep. But all that grey-blue area, this is all the area that's been mapped by the Falkor in the past few weeks. So extensive canyons, very, very complex environment, really dramatic seafloor. Because we were quite curious what was there. We thought there would be lots of canyons, but you know, it's certainly confirmed this is a very eroded environment. So the deep Great Barrier Reef is far more weirder and complex than we ever imagined, including that, you know, you can still go and find 500-meter tall coral reefs on the edge. So lots more larger boulders and fragments. They definitely have that kind of shallow coral look about them, which means they probably tumble down from up above. Oh, this is a really obvious coral colony. Oh no, I'm wrong. This could be a sponge. Yeah. Could we give this a boot, guys, just to see if it's soft? If it's soft, it's probably a sponge. There's living sponges all over the top of it. But yeah, this might actually just be a big sponge colony. Yeah, the white translucent is the living sponge colonies. But we're just going to give it a push here. It's good old push with the claw. That can tell us a hell of a lot. Yep, it's all soft. It's definitely not coral. We're looking at a big sponge colony. There we go, brittle star heading off. And for those joining from colder parts of the world, it's a lovely day here on the Great Barrier Reef. The sun is shining, the seas are absolutely flat. Nearest Great Barrier Reef is about 6 kilometres away from where we are. And John's now on Waikas. He's just showing a fisheye view of what it looks like at the back here. As I say, it's just like a swimming pool. You could just dive in and swim to the nearest reef. It's been lovely here for the last few days. Yeah, definitely seeing more boulders which look like shallow coral boulders that just actually roll down slope. And there's another perspective of the area we've been mapping over the last few weeks. And none of this was known about until the Falkor came up here. And you just see this ledge that appears. That isolated reef is Southern Small Detached Reef. And then we've got all of there's 7 other detached reefs that extend along the Great Barrier Reef shelf here or upper slope. And now we've added one more 500-meter tall reef. And as I say to people, it's not every day you discover a new 500-meter tall reef inside the Great Barrier Reef Marine Park. So this is a special dive. It allows us to try and make sense of what we're looking at here, get some rock samples we can use for age dating, and of course see what's living here on the edges of it. And some of these boulders have got a fringe of these white, very delicate white coral colonies. These are stylastrid hydrocorals, typically found in these depths. We're around at 380 meters now, so we're about halfway up this this reef, and it's just getting steeper and steeper. But we have all day to explore it, and it's like true mountain climbing with an ROV. We're going to get right to the top, probably around 40-50 meters deep. Big question is, are we going to see living shallow water corals on the top of it? There's a Echiuran worm just here, just passing under us. Can you just stop here for a moment, please, J-Rod? Would you mind going down and giving it a boop, just to show people this is a worm, a proboscis of a worm, and we've seen them very long, meters long in places. The actual main animal of the worm is on the right-hand side. You can see a little hole there, but this proboscis is a classic sort of Y-shaped, really easy to spot. And if we just bump it, you'll see it'll withdraw. The white flakes in the background, these are Halimeda green algae flakes. They can only grow in shallow waters. So there we go, there's the worm withdrawing. So this is an Echiuran worm. It's pulled its proboscis all the way in. So the main animal is like a big sausage-shaped animal. It's just down in the sediment. And I've never seen that exposed, but you always see the proboscis draped across the seafloor. Yeah, so we're getting shallow water coral debris and this white flakes of this Halimeda. Halimeda looks like little cornflakes, like fronds, about the size of your hand when they're living. They're green. The green, they photosynthesize, so they only live in the photic zone. But when they die, they break up. Each flake is about the size of your fingernail, and then they make up a really large proportion of the calcium carbonate that's produced in shallow reef environments. So it's not just coral that makes calcium carbonate. It's also a lot of the carbonate material is just from algae, and there's plenty of it here. So no living Nautilus yet, but we're kind of getting to the upper limit of the depth zone that we find them in. We've found them in the past between about 300 and 800 meters. So we're now at 360 meters. We may not get one today, which is, well, you can never guarantee these things when you're looking at nature. We have seen some of the dead shells, which means they're definitely around, but no living Nautilus so far. And here's an inset picture, 3D view. You can see the white line. This is where the SuBastian's been so far, and we're just tracking up the side of this relatively steep reef. It'll get even steeper as we get higher up. We think at some point it's going to go vertical, and then we'll climb around onto the top of the crest. So it really does feel like mountain climbing. Yeah, it definitely feels like a scree slope here. Lots of flakes, and this looks like outcrop here, guys. This might be worth stopping and getting a sample. Just somewhere where it looks like it's not just rubble. Oh, okay, we got an interesting fish in the background. Now, I would have said a bannerfish, but I'm hoping our fish experts can tell us what we're looking at here. It's 346 metres. Okay, Antigonia, deep water boarfish. Thanks, John and Will. Will White and John Pognowski from CSIRO, our fish taxonomic experts. This is a great picture there. Probably a bit stunned by all the light. It's a pretty strong light down here from the SuBastian. Yeah, just anywhere that's not too obviously with the debris. The J-rod. No, that looks a little bit like a debris field. You went over a bit of outcrop earlier, just before we got to this stretch there, J-rod. Yeah, so now it's becoming more. It's just on the left here. To see this area here, that looks a bit like. That looks a bit more outcrop-like. Alright, we're just going to try and snap a piece off here. We record the depth, of course, and it's really important for getting a sense of the age of this reef. Well, pretty tough. But if we get a piece, it's that fresh face that we're really interested in. Just like if you had a geology pick on land, you're always trying to break off that nice fresh piece so you get away from the weathered, exposed surface. Just trying to find a good part of the rock that we can lever it off. Yeah, as Marty said earlier, it's no easy thing when you're neutrally buoyant. But we can't pick up any old piece of boulder, so we've got to really look carefully for something that's a bit more outcrop-like. Yeah, it's pretty tough old limestone.
Pretty hard.
Yeah. Wow. We know how tough it is. We had the guys here made a drill bit in their workshop, and we're hoping to drill a nice perfect plug of coral out. It just didn't happen. We ended up just polishing the rock. You know, so steel on this limestone rock is still pretty difficult. Anyway, if we have no luck here, we'll just have to continue upslope. But no, not a bit tough for us. We're going to have to look elsewhere. So we've got a few pieces from further downslope, around 500 odd meters. So we're going to try and get some samples as we go upslope as well. But we're trying to avoid these scree slopes. So we're looking for some nice outcrop limestone. But of course, the trade-off is it's usually pretty tough. Yeah, so how heavy is the SuBastian in air there, Gerald?
3,200.
3,200. So we're looking over three tons of SuBastian, but down here it's neutrally buoyant, so it's just, you know, whatever the claw pressure, I guess, can lever off pieces of rock, and you know, as you can see, we're not always successful, but positive, which means you're a little bit heavier. No, a little bit lighter. Yep.
Until you fill us up with rocks.
Yep. So we were always going to collect a lot of rocks today. So J-Rod was saying he made it a little bit lighter. So as it gets anchored by rock samples, it becomes more neutrally buoyant. So there's a lot of planning goes into these ROV dives. You know, from the track where we want to go. From a science perspective, we're always after, I guess, the greatest diversity. So we're looking for the greatest amount of habitat change over the shortest horizontal distance. And then we look at like environmental, like the weather conditions. That's a really important factor. Where's the wind coming from? Where's the waves? Where's the current? And you know, we all talk amongst ourselves to try and decide what's the safest path for the ROV. We always have a plan B. Today's pretty easy. We're on a kind of big steep slope. We've got deep water all around us, and the weather conditions are just beautiful. So we don't really have to worry about any wind or waves right now. Yeah, seeing lots of scree material, lots of boulders, gravel in big sheets. This seems to be a feature of all of these steep reefs. You don't just have a blanket of scree; it's directed into chutes, or you know, it's concentrated in certain areas. But I'm seeing a lot more of these stylastrid hydrocorals, these really delicate white corals. We've sampled them before. They're very easily broken, so it just says, even though we're looking at scree slopes, they've probably been here for a long time. Lots of boulders, gravel. Oh, a big boulder coming up in front of us now. Might have a bit of a look around this. Thanks, J-Rod. There's lots of things that using them as habitat. Yeah, this looks like a big boulder from rolled down slope. Some smaller fish in the nooks and crannies. So it's not unusual to have big boulders like this in coral reefs, because this is cyclone country. When the tide goes out here, you can actually see big boulders sort of being knocked out by coral reefs. By cyclones, and they're just kind of pushed up onto the shallower parts of the reef. Is this looks like a black coral here. You see this? It's feather-like. Yeah, it looks like a black coral. Yep. Okay, we're just having a chat with our colleague Jeremy Horowitz. Yep, we've putting out our black coral alert to Jeremy. We're just trying to get some input from him from ashore through some of our other communication tools.
Jeremy wants to look at it for another 30 seconds.
Zoomed in.
Yep, if possible.
Just having a real close look in, and we'll focus on the polyps here. Yeah, so black corals they're a hexacoral, so the polyps themselves are 6 tentacled, but it's not an easy thing to count, as we've learned. We know the black corals are named because when they die, the skeleton's always black, sometimes used as jewelry. And Marty's back from lunch. How was that, Marty?
The usual standard, usual high standard. Crumbed fish, which I think might have been whiting.
Yep, collect it. It's in a bio box.
What bio box would you like?
Can put it in. Is it like pretty small?
But you can't use the living polyps as a judge of black coral. They come in all different colours, don't they, Marty?
Yeah, they do. Yeah, some of the ones we've seen have been quite colourful.
Yeah,
I always thought that they were white and the black skeleton on the inside, but no. That's been an education for me to see what the diversity and colours are.
Yeah, everything from white through to dark purple but yeah, the characteristic skeleton remains black only when it's dead.
Yep.
But just from the living polyps, it's really hard to tell. Yeah, Jeremy, if you can describe a little bit more about the polyps. They are unusual. They're not an easy thing to count.
And some of the polyps on these black corals have been absolutely tiny, haven't they? It's very hard to get a good zoom in on tentacles and other morphological features.
There's a really nice
Let's go in a bio box.
stelastrid coral over on the right here.
If it's small enough, we can put it into 1C.
Yeah, so while you're gone, Marty, seeing a lot of boulder material. It's becoming more and more coarse all the time. Some really obvious coral colonies rolled down. We try to grab some outcrop coral, some limestone. Couldn't do it. It's just
Too hard.
Too hard.
Yeah, interesting.
Yeah. Yeah, look how the water temperature's warming up. We're at 14 degrees C now, so we're pushing through that thermocline that we see around that 450 metre mark. So we're definitely warming quicker. We're getting up in that photic zone. Water temperature is going to continue to go up.
Oh, getting a good perspective of the slope now too.
Yeah, getting steeper and
Steeper.
steeper. Yeah, actually, we're almost at the end of one of the transect that's going to
Yeah.
come around on the western side of this
Yep.
500-metre tall reef, and it should even get even more steep.
Yes.
Lots of urchin tests.
So is this the type of limestone that you tried to sample
Yeah.
before and it was too hard?
Yeah, yeah. We got right under it and we're
Yeah.
trying to break it off, but
Yeah.
it's just too tough. Oh, that's pretty. What have we got there? Little soft coral colony right in the centre. Big polyps.
Bright, isn't it?
Very pretty. I wonder if there's a crab on the bottom of it. That would win
Wearing
the.
it.
That would win the hat.
Fashions in the field.
Yeah, fashions in the field. Yeah, and yeah, lots of halimeda.
All right.
Your
Yeah.
favourite
Yeah.
halimeda? Yeah, heaps of it. So
Okay.
that's
Well, that is
a
interesting.
good sign for what we have higher up.
Yeah.
That it won't be this desert or
Yeah.
bare face. Hopefully, we'll see halimeda and shallow water coral.
Fingers crossed for that.
Oh, is this one of these
Little-
epigonas? No, reaching out to our fish people. Almost looks like a goldfish.
Tiny little thing.
Big
isn't it?
eyes.
Yeah, it does look like a
big
goldfish.
eyes. Really big eyes.
Grammatognathus?
Yeah, that's a bit of a mouthful.
Grammatognathus.
Grammatognathus. Have I got that?
Grammatognathus calanthidae.
Yeah, beautiful colour. Let's see if we can find them again. Just zooming out. Where did it go? So we've got a few other, we've got some other cameras here to help us guide us here. Look at this there, Marty. This is all shallow water coral pieces.
Branching coral.
Yeah.
Fingers of branching coral.
Fringe of stellastrid hydrocorals. We have seen this consistently in all of these deep reefs at this depth. Oh, big sponge coming into view now. Okay, so this is a siliceous sponge, a hexactinellid sponge.
So silicious, meaning that the spicules are all made of glass, silica,
yeah.
which essentially is glass.
Nature's glass.
Yep.
Yeah. So this is soft. You can see all the big pores, and we've been fortunate to have Merrick Eakins with us as part of this expedition.
That's right, yep.
So he's a deep water sponge expert. He's the curator of invertebrate taxonomy at the museum at the Queensland Museum in Brisbane. So all of this sponge material is heading back to Brisbane
Yep.
to be registered at the Queensland Museum, and then of course all these samples end up going to experts all around the world. It's part of a big network of taxonomists to help us describe and understand the deep water fauna in the Great Barrier Reef here. Another black coral. Looks like the one we just sampled, don't you reckon?
Sea cucumber.
Oh, I wasn't expecting that.
It's
a bit
precarious on the
Yeah.
side of this.
Yeah, it's
cliff,
moving.
Isn't it?
Yeah. It's very rubbly. Oh, look at
Oh,
the
it's
top.
got a friend. Is it a nudibranch or another cucumber?
There's a baby cucumber. Okay, we need to. Oh, is this a nudibranch that's just coloured?
Is it a nudibranch disguised as a cucumber?
Yeah, we
Or
need
is
to
it a
have
baby cucumber?
Closer look at this, guys. The heck is this? it looks just like a cucumber. See, the
Similar
larger
markings
cucumber.
and colouring. But is that just a disguise?
Yeah,
I think it's a cucumber.
it's moving pretty quick though.
Yeah, I think it's a cucumber.
Okay, we need help here. Or is it just some mimicking nudibranch?
Yeah. So a nudibranch would have its feathery gills on the outside.
Yeah, yeah, that's true. Yeah.
I don't know if there actually are gills, but its lung-like appendages would be on the outside.
Yeah, no, they are gills.
Yeah, they're gills. Yeah.
Nudibranch means naked gills in Latin, perhaps. So, but I mean, one of those bumps could be a gill. Really unusual. I've never seen like hitchhiking
Yeah.
baby cucumbers on.
Yeah.
Yeah, I mean, because most of these echinoderms, they're broadcast spawners, right? And when they spawn, they shed their eggs and sperm out in the water column, and they drift away.
Yeah.
Eventually, become, like juvenile animals. They're a long way from their parents.
Yeah,
right?
so there's no sort of parenting, maternal
No,
behaviour or anything
no.
like that. They're just once they're on their own.
Oh, a boarfish in the background. Just there's a lot
Ah,
happening here.
well spotted.
Yeah, just in the darkness. There we go. Just keeping an eye on us. But look at this fringe of stellasterid corals here. This just looks like a big boulder that's rolled down. So.
Yeah, yeah.
Now, what's this white colony?
It's branching.
Is this another
Colony?
stellasterid or something
I
different?
don't know.
Just getting a zoom in. Oh, there's a hermit crab book in the background. There's a lot going on here. Oh, Seagull's saying scale worm. That's
Ah, there you
Polychaete.
go. Scale worm.
interesting.
So
Well,
that would
you
be
would-
be mimicry then, wouldn't it?
It would.
Yeah.
It would. It looked just like a mini version of a cucumber.
Yeah.
With the same coloured dots on it and everything.
Oh, there's Russell Kelly online. G'day,
Hey,
Russell.
Russell. I reached out to Russell earlier today. Welcome aboard, Russell. Ah, okay.
So
Scale
scale worms are
worm.
also common on holothurians. Thank you for that.
Yeah, thank you. Yeah, so we really appreciate all our experts ashore helping us. Oh, look, actually, if we can just before you leave there, J-Rod, can you just zoom down? If it is, it's just left. You can see it moving down away from the sea cucumber. There you go.
Just curious to know, Russell, just reaching out and saying hi. Have you been following a few of these dives, or is this the first one that you've tuned into the live stream?
Check for the head tentacles pairs, yeah. It's got a lot of shape on it, hasn't it? There's these sort of higher bumps on the top. It's very active. I mean, now I'm looking at it, it does look polychaete-like. There seems to be lots of little legs pushing underneath. But yeah, check out the coloration. It is a real mimicry, isn't it? Yeah. Yeah, it's great to have you joining us. Russell's one of the foremost shallow coral reef researchers.
Yeah.
And has a reef guide that many people might be familiar with. I was first introduced to Russell when he was putting out those like plastic cards that you can use underwater to help you identify the incredible diversity of shallow coral reefs.
Yeah.
And it can be a bit bewildering when you start doing this, all that colour and shape. But in fact, there are, when you break it down into the different shapes, you realise it's just a variation on the different types of corals, and it's not so mysterious. So Russell has probably done more to demystify the variety of coral reefs than probably anyone on Earth.
Yeah, make it easily accessible to scuba divers and everyone, as well as researchers.
Yeah, you don't want to leave just reef research in the hands of experts. It really needs to be everybody. I mean, they're the challenges that shallow reefs face all over the world, and it's really up to all of us to understand them better. So Russell's Coral Reef Guides helps us do that. Now we're looking at an old sponge skeleton here, perhaps there, Marty. Just what's left. Yes, hermit crabs. The seafloor's all moving around, and there's hermit crabs on top of it. The colony, and we've got some beautiful brittle stars too, and these lovely, delicate white corals. These are the stellastrid hydrocorals.
So feel free to jump in with any ID information, Russell. That would be greatly appreciated on board here in the control room.
Yeah, lots of hermit crabs, but the boulder it's on looks like a big colony, an shallow water coral colony.
Yeah, you can see the skeletal structure.
Yeah,
of
the corallites just popping through.
Mm-hmm.
So we want to keep looking under some of these ledges. Have got really interesting marine life underneath them. There's a polychaete worm up here with its antennae out.
Yes.
So because there's so much sediment coming from the tops, the shallow reef at the top, I always call them, it's like a big carbonate factory, that it can suppress the marine life. So the ledges are great places to find animals
He's
like
just
corals.
retracted those tentacles.
Yeah, lots of nooks and crannies here there, Marty. Boulders over on the right. Getting very bouldery now. But they've got that patina, that dark patina from the ferromanganese oxide. Tells me that looks like it's been here for a while.
Yeah. And that sort of castified morphology. Lots of grooves and crevices and nooks and crannies, which we would expect, but they're kind of smoothed over.
Yeah.
These.
I'm seeing lots of little movement here. You may not see it in the YouTube vision. We've got a sharper vision here in the control room, but seeing lots of little hermit crabs moving around on the seafloor. We're at 300 metres, it's 15 degrees C. So it's warming pretty quickly now. So we're coming around onto that steeper western face there, Marty.
Yep.
Now the black coral sitting on top of this rock.
So we plan out the dive transect the night before, don't we? Or the day before. We look at the multi-beam mapping that we've already collected. We look at the backscatter, and from that we sort of decide where we'd like to do the dive, taking into account all sorts of parameters,
Yeah,
depth
lots of
and
debris
time,
here.
and the situation, where the ship would be positioned, where SuBastian would be positioned.
Yeah.
Is that a sea pen, or is that a...
Here's an inset view of where we're diving at the moment. So this is the smaller of the two detached reefs that we're on. You can see the white track. That's the SuBastian's track so far. We've been in the water since 9 o'clock and it's midday, so 3 hours. Got about 3 hours left. Looks like nice black coral. And it's a real mountain climbing ride today. We're flying up the side. We're halfway up and we're aiming for the summit. Marty, you might go and grab some lunch.
Enjoy your lunch break.
Yeah, see if I can get one of the other team to join you.
Might be downstairs too. Thanks, Rob. If you've just recently joined us on this dive, we're diving on a newly discovered or newly mapped 500 metre high coral reef in the northern Great Barrier Reef, which hadn't previously shown up on any previous multi-beam mapping or nautical charts. And it was just with our systematic high-resolution mapping surveys that we've been doing with RV Falkor that this reef was uncovered or revealed for the first time. So we obviously, with ROV SuBastian, have the opportunity to dive here and check it out and see what type of reef it is, what's making up the substrate at the base of the reef. And certainly the big question for the day is what will we find on the top? What sort of habitat will we see on the top of this reef? The top of it is in about 40-ish metres of water depth, so very much well within the photic zone. A little deeper than your typical shallow coral reef that you see on the inset there in the red. The red and orange colours on the top there is what we call is LiDAR imagery, and that's very shallow and high resolution. So the red are the coral reefs that are more or less at sea level or close to sea level. So we're 40 metres below sea level at the top of this reef. Doesn't have a name, of course. We've only just found it. So in the meantime, we're just calling it the 500-metre reef. Sebastian, TT Reef. TT, Team Texas. Got J-Rod and Cody piloting and co-piloting at the moment. And this is one of these detached reefs. We're in an area in the northern outer edge of the Great Barrier Reef. Oh, rock. Yes, please. Any of these ledges? Anything from any of these ledges. So it doesn't really matter if it's not pointing to where or which one, just wherever you can get just to break a piece off. Thank you. As long as it's not a real loose cobbly one. Yeah, so that's been a really exciting discovery for all of us. So I guess in time, in due course, the Great Barrier Reef maps will be updated, and this new reef will be included on whatever's the next iteration of Great Barrier Reef Marine Park maps and spatial data. So for the geology science team, we're interested in collecting samples of this limestone. This limestone represents older, different phases of reef growth from in the geological past. And there's a whole lot of information locked up in these rocks that we can uncover back in the lab using geochemical techniques. Trying to age date some of this material is quite challenging. If it's well preserved, we can date, but if it's not well preserved, if it's been recrystallized or altered in any way, it makes it quite challenging to try and date. But we can look at other information like trace elements, and this stuff is very, very hard. So this limestone is literally cemented with calcite cement. Joined in the chair now by Vicky Lowe from the University of Queensland, who's one of the scientists on board, who's just also come back from lunch.
Yeah, but I just had lunch.
Sort of the...
You take that whole thing. I got it.
We can't obviously take the whole thing. Are you able to snap it? Did you want to introduce yourself, Vicky, and tell us what you work on, which is not tropical reefs?
Not tropical reefs. My name is Vicky. I'm from the University of Queensland, and I work on Paleoceanography, so reconstructing past ocean conditions using radiolaria, which are tiny little glass fossil, glass plankton, and we look at them down core in the sediment record, look at the fossils and reconstruct past conditions with those. But that's all cold water conditions a long way south from here.
Doesn't want to break. I think he's sitting on the back.
But there are, there's certainly the water that I study down in the Southern Ocean. It travels all the way up here, and once we hit about 500 meters here on the reef, we're in the water that was created down in the Southern Ocean. So yeah, even though it's not really, the reef isn't my thing, the water that I study still makes its way all the way up here. Oh no.
That's all right. Too big.
Oh no.
As much as I would love to keep it.
Yeah.
It's just not practical.
Yeah.
Not practical. It makes collecting and stowing any other samples quite challenging.
Yeah, it does. Especially when we know there's a lot more coming further up.
Yeah.
Glasses.
Yeah. Yeah, anything's in there is fine. Maybe try in there, maybe. Yeah.
It's interesting looking at these reefs because they're just so exposed, and it's no surprise that there's this debris everywhere.
Yeah, for sure.
Yeah.
Even just normal erosional processes from wave energy does this, and then of course we get cyclones passing through here as well.
Yeah.
And so cyclones can move huge amounts of material. Some of the reef block boulders that you see thrown up on top of the reef,
Yeah.
the shallow reef that's at sea level, some of them are massive, and it's cyclone energy that has done that.
We're coming up to cyclone season, so
Yeah, that's right.
it'll happen all over again this year.
About another month, I guess we're officially in cyclone season then,
Yeah.
aren't we?
So we've made it just in time to avoid those.
Yeah. Yeah, we'll be heading back to Brisbane just in time. I mean, cyclones, of course, can occur any time, pretty much from about December through to about April.
Yeah.
And, up here in the northern Great Barrier Reef in the tropics. Down in Brisbane, we tend to get the tail end of the sort of the low pressure, the what do we call it, a subtropical low pressure system.
East Coast lows.
East Coast low,
Yeah.
Which brings a lot of rain, a lot of wind and rain. Oh, there you go. Perseverance. Thank you. Oh, it's little.
It's only a little one.
I'll keep that in case you don't get it. Get these. I think 1D. Is that 1D? Oh, what's the meaning of the stars on the right collection box, please? Ah, okay. So there's a question on the Facebook chat asking about what are the stars on the lid of the right collection box. So actually they're not stars. So
No,
we've,
they're not
we've
stars.
got a message written on the lid of the collection box by one of our scientists on board, Joan Lee, who is a master's student from James Cook University in Townsville, and that is a message to her mum, wishing her mum a happy birthday. Which is a nice little birthday treat to have your birthday well wishes coming from 500 metres below the ocean, isn't it?
Absolutely.
Delivered via ROV.
And tomorrow it's a Dougal dive, and apparently it's Dougal's mum's birthday tomorrow, so maybe we should write a message to Dougal's mum.
Yeah, we should.
This rock is not wanting to give up today.
No. So the limestone gets cemented together with calcite cement and literally becomes hard as rock. So
Yeah.
challenging. Let's grab a piece. We did get one little piece, which is better than nothing. Oh, there you go.
Yeah, nice work.
Nice. You can just go and deal with the other piece. Very good. (270 meters, 15 degrees Celsius.
We're getting
So we are
there.
getting there.
How many waypoints do we have today?
I can't remember.
There's quite a few. By the looks of that, we might be up to nearly 20. Because we've got a fair traverse across.
across the
Yeah,
top. It's alright, we're making good progress.
yeah.
Nice. Keep going. Okay.
It's hard to believe we're on our second last dive for the cruise.
Yeah, it certainly is. So tomorrow will be the last dive for this expedition. It'll be the last dive for ROV SuBastian in Australia this year.
Yeah. It's gone very quickly.
It has gone really quickly for me as well.
Yeah.
ROV pilots will be going home for a well-earned break.
Yeah. Counting down the days, no doubt.
And done the hours.
Yes.
4 days.
It's alright.
3 days and 18 hours. Sad for us, but exciting for them.
Yeah.
So there'll be no ROV dives on leg 3 of this expedition. We'll be doing a lot of multi-beam mapping. And hopefully, if the conditions are good, we'll get to explore some of those coral reef cays, coral islands on top of the Tasmanian seamounts as we make our way southwards down towards Brisbane. And ending the voyage in Brisbane on the 17th of November.
Yeah. It's been a quick 2 months, really.
So we have a port call in Cairns in the next few days where we'll be swapping out most of the Falkor crew, not all. And 3 of our scientists are getting off. Rob, Joan and Valerie will be leaving us in Cairns. And you and I will be staying on for leg 3.
Yeah, doing the mapping.
And we'll be picking up Luke Notiff, a marine geologist from Queensland University of Technology in Brisbane, who was with us on leg 1, will be coming back and joining us again for leg 3. So the RV Falkor is one of the few, if not the only, research vessel that has been able to continue working and exploring throughout the COVID-19 situation. I think there's 1 or 2 vessels that are back out now. I think Nautilus is out working, and I know that the IODP drilling ship, the Joides Resolution, is out at the moment too, and I think the RV Tangaroa from New Zealand is out working right now as well. But prior to that, I think the Falkor was the only ship that was still able to continue working and operating. Falkor's been in Australian waters since December last year, but has been able to stay in Australia throughout the duration, and hence has been able to continue operating. However, most of the scheduled voyages had to be either cancelled or rescheduled because they involved international scientists or equipment that needed to come from overseas, and of course COVID interrupted all of that. Oh yeah, thanks Will. Our RV Investigator, the CSIRO vessel out of Hobart, is out now, down at exploring Macquarie Ridge, Macquarie Islands, part of Australia's sub-Antarctic territory. And actually that expedition, I was scheduled to go on the originally scheduled Macquarie expedition, but then it got cancelled and rescheduled, and I turned down the opportunity to go on the rescheduled voyage, and then this opportunity came up, so
Yeah.
so if I wasn't in the tropical waters of the northern Great Barrier Reef right now, I would have been in the sub-Antarctic waters of Macquarie Island, and I've got to tell you, they're being thrashed down there too. The weather is they're rolling around a lot down there at the moment. So,
Yeah, the Southern Ocean's usually not very nice to
yeah.
to the
In
scientists.
hindsight, I'm glad I'm here and
Yeah.
not there. As much as I would have loved to have gone to Macquarie Island.
Yeah. Well, hopefully I get down there at some stage. Part of my PhD will be on the Macquarie Ridge, so it would be very nice to go down there and see it. Not necessarily comfortable, but it would be good.
So is that on the investigator voyage that's scheduled for next year, or is it the year
No,
after?
I won't be going on that one the year after. But that's not to Macquarie, that's down to the Antarctic coastline.
Okay.
Yeah. Yeah. Oh,
What have we got here? What? Oh, it's an egg sac. It's a shark egg
yeah.
sac. A mermaid's purse.
Huh.
Yeah, can we examine on that?
Yeah.
Yeah. So, yeah, I think that is a shark egg sac. Waiting for our fish people to catch up.
Catcher.
My sister Jodie suggesting the new one, Jodine Pinnacle. Yeah, good one, Jodie.
So perhaps a cat shark. Will's saying a cat shark.
Ah,
Purse.
you. Attached to, I guess, it's a black coral. Jeremy, if you're watching, we're reaching out to you with respect to potentially collecting this coral. And, Jeremy, have you stepped out to lunch yourself? Or are you still with us?
Yeah, we go to the reefs this side.
While we're waiting for a comment from Jeremy, we'll have a good look at this egg sac. It's a shark egg case, possibly a cat shark.
Yeah, this is one of these like mermaid's purse
Yeah.
shark eggs. So can we see the yolk? Is this the yolk that we're seeing here?
I
The
think so.
like a ball of like nutrients, and the animal
believe so.
would be behind it. Like the shark would be sitting behind it.
Large yolk down the bottom. It could be an Empress egg case. Is there a common name for that, Will?
Empress egg case, rightio, okay. Because the babies, when they hatch, they chew their way out of these egg cases, don't they? I've seen lots of empty ones that have got a little hole in there where the shark's chewed its way out.
I've only seen one where you could very clearly see the embryo. You could see the embryo wriggling around inside there. I've only ever seen that once.
Yeah. Well, we have an aquarium at James Cook University run by Richard Fitzpatrick and Jamie Seymour, and they sometimes have these little live, epaulet shark eggs, which are just like this, little mermaid's purse shark eggs. And when they hatch, they're the most cutest little shark you can imagine. Yes, we just had a discussion here. Jeremy stepped out. We don't know if he needs to take a little piece of this coral, this black coral, but the reality is all of the animals, all the biology that we take are all done under a permit that's issued by the Great Barrier Reef Marine Park Authority, and we don't have a permit to sample fish or sharks, and so this being even a shark egg, we can't actually keep it. So we're just going to have to make do with the vision, which is of course excellent. But no, unfortunately we can't collect fish and sharks, so we'll just have to stick with the imagery. Sorry about that, Will. We may be able to just do a little.
Leave the egg, put it in one branch for the buttercups. Do you want to put it in your safe cooker? Not just in freeze, but just so it doesn't fly away. I think it's not floating. Not floating? You can put it in box 1A. Yeah. Magic starts.
So it looks like we're going to take a small sample of this this black coral. Just
Not the whole thing.
yeah, that's right. And then we'll leave the egg alone. But it's great to see a fresh one. Most of the time, you just see them washed up on beaches.
Yeah.
Great colony. Of course, we've seen other animals with eggs. If anyone was watching when we did the previous expedition, we were out near Osprey Reef, and it was a really deep dive. It was over 1 kilometre deep, and we saw a big octopus brooding its eggs under a rock.
Oh,
Do you
yeah,
remember
that's
that?
right, I do remember that one.
That was spectacular. All the baby octopus eggs attached to the top
hanging
of
down from the top of the sort of little cave.
and the octopus, really big octopus, just hanging underneath it. And my other brother Greg is saying it should be Greg's Pinnacle. Yeah, we don't know what the whole naming process in the Great Barrier Reef is actually quite protracted. There's lots of rules around it. Usually you have to be dead for a start. You have to be some prominent person, typically.
I imagine it would get named in some way that connects it with the other detached reefs. So perhaps something detached reef.
Yeah. But you know, a lot of reefs are named often by the people that discover them, or certainly in the old days, the 1800s, lots of reefs were named after the ships, the various vessels that first bumped into them, unfortunately. Speaking of which, we were sailing along the Great Detached Reef yesterday, and the weather was beautiful, flat seas, the tide was dropping, and I saw a really large Admiralty anchor sticking out of the reef. And you know, they're not a common anchor you see, but very obvious, big flukes, very rusty, just embedded in the coral. So it just speaks to probably an old shipwreck that once ran into these reefs. Jeremy's saying it's a branch Parantipathes.
Just waiting to confirm that Jeremy just wants it in a bio box and not. Yeah, he's only just come.
Is it 192?
He doesn't want it in the quiver. Be okay?
Yep.
Well, Jeremy's certainly done well out of the black coral sampling on this expedition and the last one, because I remember doing my first trip with Jeremy out in the Coral Sea. We were out there for a month and he didn't collect a single one.
Right.
So a lot of.
So they just weren't there, or you didn't have permits to collect?
No, it wasn't that. We were using a different technique. They were what's called a rock dredge, which is just simply a chain bag. It was going really deep, down to 4,000 metres, trying to dredge up these bits of volcanic rock at the base of the Tasmanian seamounts. And, you know, the rocks would come up with biology attached to them, but just not black coral. So Jeremy was the sole biologist on board on a ship full of geologists, but he did a great job dealing with that biology, even though it wasn't his target species. But you know, since the Falkor has been out here and we've had the ROV, it's really amazing, just the diversity of black corals from the really cold, deeper depths right up into the shallows, pretty much everywhere. That entire water column so far. Gee, it's getting steep.
Those really deep, cold ones are the ones that are really exciting for Jeremy.
Yeah.
He's collected many new or undescribed species on these trips.
Wow, look how steep that is.
avalanche territory for sure.
Yeah, yeah. I saw you. I was having lunch and I saw you
Yeah.
pick up that big ones. Like,
As tempting as that was, that would have been completely impractical. to
yeah,
try and do
yeah,
that.
yeah. This is like coral Jenga, right? You know, you want to be sure the bit you're pulling out doesn't bring everything else down on top of you.
So on a previous dive, we collected a fairly big rock sample that we wedged down in between the bio boxes, which was fantastic. But what it means is then, for the rest of the dive, every time you want to sample something and put it into one of those bio boxes, first you have to pick up the rock and move it out of the way, open the bio box, put the
Yeah,
sample
yeah,
in,
yeah. We had that.
put the rock back.
That dive into the plunge pool was a bit like that. We were completely chock-a-block with samples and strapping it to the roof, weren't we?
That's a question from Glenn on YouTube, Falkor team. What do you watch after dive season?
Yeah, good
Battle
question.
withdrawals from doing this day to day. Well, after dive season, we have all the work to do in the lab, so
Yeah, that's right. This is really only the start of the work, frankly. The data and samples and work will continue for many years after this expedition. But I have to say that being here on these dives is completely addictive. I would never have thought I'd have this experience. With COVID, it's only really come about through the whole COVID crisis that we've been able to. Well, the Falkors had to remain in these Australian waters and within Queensland, these waters off the Queensland coast just because of state borders closing. But here we are, it's our third expedition with the Falkor in Great Barrier Reef and Coral Sea Marine Parks.
yeah. It's what we call opportunistic science, and certainly has been a really wonderful opportunity, hasn't it?
Yeah, I mean, the mapping has been superlative.
Yeah.
But there has been no really big systematic multi-beam surveys in the deeper Great Barrier Reef waters ever. And the Falkor is just completely giving us a step change understanding in what's down there, particularly on these northern parts of the Great Barrier Reef, which have never had any real decent multi-beam mapping done. And so we've been here for nearly 4 weeks now, just systematically mapping, 100% mapping from the shallow Great Barrier Reef all the way down into the deeper waters in places over 2 kilometres deep. And it's been every day we just go, wow,
It's been
look at
something
that.
new every day, hasn't there?
Yeah.
Even if it's not a dive day, if we've just been mapping, yeah. Very exciting. At times it's overwhelming, all these amazing things coming into view on the screens or what have you, and sometimes it's hard to wrap your head around it all.
Yeah, that's right. I get very
Once we
excited.
get home, I think, and reflect back on everything,
Yeah.
the significance will really start to hit home.
That's right. So probably we do need that break. We need a chance to reflect on what we have here. And because as scientists, we're trying to explain or give trends or, try to make sense of this very complex natural world, a world that we've really never seen before. And, as geologists trying to make sense of how these structures formed. Here's an insert view showing the mapping we've done. This is this blue-grey brown colour. This has all been mapped in the last few weeks. So if you imagine everything, all that area that we've mapped, that had never been visited by any multi-beam before. So we never had any understanding of the complexity of the seafloor in this far northern Great Barrier Reef.
So the red, orange, yellow colours, that's LIDAR. That's up in the shallow continental shelf. Those are coral reefs that are at or close to sea level, that are mapped by airborne laser depth sounding. And the multi-beam mapping that we've been doing with RV Falkor is this deeper stuff off of the edge of the Great Barrier Reef on the continental slope in those sort of, brownish to whitish sort of colours.
That's right. So the depths there are around over 2 kilometres deep when you get down to the lower limits. This is all part of the Great Barrier Reef Marine Park, which extends far beyond the continental shelf itself. And for me, it's been this great goal to get up here and map it in detail. And it's just been a real privilege to be on board and see everyone at work. The multi-beam mapping team, the bridge team, everyone's working together to map this really unknown and unexplored part of the far northern Great Barrier Reef. So we still have a few more days here. After the ROV's recovered, we'll do some more mapping through the night. We're just trying to map in around these detached reefs But you can see this this one pinnacle, this new 500-metre tall reef, discovered for the first time. It's one of a collection of 7 detached reefs that stretch about 100 kilometres along the far northern Great Barrier Reef. Yeah, so mapped here in the late 1800s. So this would be the first the first 500-metre tall reef that's been discovered on the Great Barrier Reef in at least 120 years. And we're getting closer to the top. We're at 240 metres. The top of it is at about 40 metres. So we have 200 metres of vertical climb. And if you think of this like a big sort of blade-like mountain, we're on the really steepest parts of it now.
Great shot.
Yeah, it is. And, you know, all of us can think of this just like a big mountain climbing expedition. Crawling our way up. We're into that real steep zone now.
White trail is ROV SuBastian's track.
Yeah, so I said blade-like, and that's exactly what it looks like. In plan view, it's very, very narrow. In fact, the top of it's probably only about 50 metres wide right at the top. So we're going to bring the SuBastian up into that shallow water, and, well, who knows what we'll find there, Marty? We may show you, we might find coral, or we might find just a desert.
Yeah.
You never know unless you look.
So the rubble gives us some clues as to what we might see higher up, doesn't it?
Yeah, I mean, we've seen Halimeda down lower, unlikely to have been washed out from the Great Barrier Reef, which is about 6 kilometres away. It's more likely to have fallen down from higher up here.
Above us, higher up. Yeah, and we saw that piece of ulva, the sea lettuce, that green macroalgae on the bottom earlier on.
Yeah.
Which is a shallow species.
Yeah.
It's come down from higher up.
Now we'll start seeing red coloration on the rock, and it looks red to me. This is red coralline algae. It marks the very lower limit of the photic zone. So think about 1% of available photosynthetic light. The red algae is able to photosynthesize with that really tiny amounts of light that's down at, well, 230 metres depth.
We've jumped up a couple of degrees in temperature just in the last few minutes while we've been talking. It's nearly 17 degrees Celsius now at 230 metres water depth. Some people might consider that pleasant enough to swim in, but I certainly don't.
Yeah. Yeah, I mean, what's the water temperature at the surface here, Chris?
It's getting close to 27.
26.3.
26.3. Beautiful. So outside, it's just a lovely day. It's flat, calm seas, the sun's shining. You can see just the hint of waves breaking on the nearby coral reefs. Seeing a bit more fish here, Marty. Are these deep water anthias? Odontanthias, okay. Deep water anthias. Can we just have a bit of a look around here, please, Chris? We're going to see if we can poke our head underneath this big boulder to catch these odontanthias. And just reaching out to my wife, Diane, watching from Cairns. So I'll be home this Friday. We're having the end of leg 2. A quick crew change around. Although for you, Marty, you're just watch on, stop on for you.
Yeah.
You're staying on board.
Myself and Vicky are staying on board for leg 3.
And Luke Northdorf from Queensland University Technology is also joining for leg 3 of this expedition.
So Diane says minimum of 27 degrees water needed for
Yeah.
North Queenslanders to go swimming.
Yeah,
Is that winter temperature, 27?
No, well, it's sort of now, but you know, I don't swim in winter. It's just too cold. You know, it probably drops to around 23 degrees or something. It's freezing to us. Yeah, summer's a great time to swim in the North Queensland. I just, you know, this is when we go out to the Great Barrier Reef. We do at least a couple of reef trips. We go out to the pontoons. We stay at Fitzroy Island Resort, and we swim a lot of the creeks and things around Cairns.
Oh,
so
do you?
yeah. It's like, no, not saltwater creeks. There's too many
Looking at you
crocodiles.
sideways, going really?
Not crocodiles. Yeah, no, the freshwater creeks is a bit cold for them, for the crocs. So.
So you must have a few local swimming holes that you know are safe for swimming in summer.
Yeah, for sure. All right, looks like those antheas have disappeared, so we'll continue up. We're at 226. We're really on that. We're getting into that very steep part of the of this reef.
Very waypoint bridge.
Ooh, that's pretty.
Very nice.
Anemone,
Anemone.
perhaps.
Beautiful.
It's just like a little flower pot.
Yeah.
Okay. Yeah, you guys are talking about current. You can see it in the anemone, the tentacles being pushed sideways. Of course, this is not easy for the ROV. You have to fight against it. So we'll just see how we go as we get into these shallower waters. Yes, Diane's saying I've got house duties when I get home.
But you've got a lot of house duties to catch up
Yeah,
on.
I've had my 3 weeks of fun out here. I always say I go to sea to have a break.
I think maybe it's time Diane went on a girls' trip overseas or something.
Yeah. Definitely a holiday. We could all use a holiday. Yeah, it's interesting. The current's really picked up all of a sudden. Looks like a soft coral,
Coral.
octocoral.
What's wrapped around it?
Okay, Joe's saying it's Coronepthia. We're definitely getting in that soft coral zone, don't we? That the lower mesophotic with the soft corals really start expanding.
We started seeing those gardens of Gorgonian fan corals on one of the previous dives, didn't we? Was that
Yeah,
a little
there's
bit
been
shallower
some.
perhaps than what we are at just now?
Yeah, but boy, haven't we seen some really spectacular soft coral gardens?
Yeah.
There was that one RV dive in particular, Marty. Remember, we got in that mesophotic zone further down south, and I think it was Valerie said it was like a forest of, like, you know, they were over 1 metre wide. There we go. There's our ambient light. with the
That's at
lasers.
224 metres deep. That's remarkable, isn't
Yeah,
it?
and the lasers in the
very
middle.
Clear, clean water here.
Very clean water, yeah. And you can see the red encrusting coralline algae on the rocks now.
Nautilus shell.
Oh, fantastic. Yep, we'll just have a closer look at this. No Nautilus, we are really getting out of the living Nautilus zone, because during night time they migrate up into these shallower waters. Yep, that's a pretty good one
really
actually.
Fresh.
Yeah.
We've only seen one live Nautilus on so far this
Yeah,
trip, haven't
yeah.
we? It was sleeping.
Would you, Chris, would you mind just tipping it over, just to tip the sediment off? We don't want to collect it. If you're able to just tip it upright, then people can see the coloration on it. Yeah, so this is, I mean, we stop for Nautilus, even dead ones. We've seen lots of living Nautilus in most of the dives, haven't we? In the Coral Sea, it was remarkable.
Particularly in the Coral Sea.
Yeah, out in the Queensland Plateau, nearly all of those atolls out there had living Nautilus on them. The fact that this one is here,
You just want to tip it up, right?
yes, please, yeah, just to tip the sand off it, it means they must live here. You know,
That's right.
we've seen 2 other shells already. This is our 3rd, so you know they're definitely living around this reef.
On one of the Coral Sea expeditions, the nautilometer got up to around 7 or 8 or
Yeah,
something, didn't it, on one dive?
yeah. Like we always knew that they were around, especially from the work that Andy Dunstan did at Osprey Reef, where he did his PhD on Nautilus. But we weren't really, I guess we were really surprised at how many there were at all the other reefs.
Yeah.
Yeah, that's pretty fresh. A little bit of a break, because the animal lives within that main chamber, and that sits at the bottom. So if anyone's ever seen them swim, they have this really interesting bobbing motion. So that's the siphon squirting out water. But yeah, that's in pretty good condition. And it's got some little polychaete tube worms on the side.
Those little pink dots are encrusting foraminifera.
What's that?
Which things? These?
I see all the little orange dots everywhere. It's like stalagmite, as you can see, just these little.
Oh yeah.
You got there's a couple there, and I think there's 8. These.
Yeah, Vicky's just pointing out these little orange. What would you call them? I don't know what you
Sticky
call
uppy things.
Sticky uppy things. They're tiny. You know, they'd be like 1 centimeter, about 1 centimeter tall. Could they be little sponges, perhaps, Vicky? Little Comatulid crinoid, feather star. This is one of these mobile ones. They can swim.
So you can get forams that stick up like that too, but I'm not sure if that's what these are.
Okay.
Anyway,
All right. Onwards and upwards. 220 meters. We're aiming for about 40 meters at the very crest. That crest is just going to get narrower and narrower as we get higher up. We measured it. It's kind of it's sort of a slither-like shape when you looked at it from a plan view, about 300 meters long by 50 meters wide. So it's not very wide at all. This looks like a big colony tipped upside down.
oh yeah,
Wow.
oh, nice big anemone.
Yeah, beauty. And above it too.
Yeah.
got that yellow mouth.
Saw one earlier that you could quite clearly see the mouth, the colouring
Yeah.
around the mouth.
Now the black coral.
Oh yeah. Do you want us to stop on that one? Yep. Let's pause and have a closer look at that coral. I know there's still 1 or 2 targets that Jeremy's still keeping his eye out for.
There's another shell. Just a moment. We'll have a close look at that. And here's another
there's a-
probably black coral down here.
Some more bushy branching one.
Yeah, and also up there. Okay, starting to see a bit more.
Yeah, so you need to pay a
bit more coral.
closer attention here.
Coral action here.
Okay. So Jeremy, we're looking at a branching one now. If you're
There's a few colonies popping out here.
Jeremy wants this one. Yeah. Yeah. Zoom in and have a closer look at this one, and we'll just wait a few seconds delay between what we see here in the control room and what you all can see at home.
Okay, I don't know what we're looking at here.
Zoom in on this one.
Is this a black coral?
I think so. Okay, so this will be a collection. We'll just wait for Jeremy to let us know whether he wants the whole colony and where he'd like to put it.
Let's put it in a file box, please.
Going back.
Yeah. Sure.
Aphanipathidae.
What?
Aphanipathidae.
Oh, that's a mouthful. Aphanipathidae. Okay. It's not big. It's about probably about 10 centimeters or so. Yeah, no, it's 15 centimeters or so. So as an interview, this is the situation camera,
That's a great view.
a wider view that we have.
Gives you a perspective of how Sebastian is sitting perched precariously on the side of this.
Yeah. Vicky said it the other day really well. It's like being on the side of a skyscraper, and then you have a helicopter, and you're going to land it on a ledge, and reach out and pluck a tiny little feather.
That is a
Off
great
it.
description.
But then make the helicopter remote and drive it via cable from a kilometre away.
Where you want to put this?
Put it in 3-4 or 2. Unless this maybe 2.
Just all the tools are into.
Yeah, 3-4 is good.
4? All right.
And you might be curious about the writing on the bio box. This is from Joan, reaching out to her mum. Happy birthday message. Because being out at sea for a long time, not easy for people. Some of the crew here, Chris I think has been on for months. There's a big crew changeover coming up in Cairns at the end of this week. So a good number of the crew heading home for a well-deserved break. And you're continuing on, Marty, all the way to the 17th of November.
17th of November, we head back to Brisbane, which is home for me.
Still lots of adventures for you, though.
Yeah.
So you're going to be mapping the edge of the reef down at the Swain Reefs.
Yes.
Very,
looking forward to
very
that.
remote part of
Yeah.
the Great Barrier Reef.
Which we did a little bit of that on the first leg when we were mapping the slide, the Swain slide. So we'll continue on with a bit more mapping down in the southern part of the Great Barrier Reef on the edge of the Swain Reefs. Again, an area where the edge of the Great Barrier Reef is just very poorly defined because of this sparsity of mapped data points that you have to interpolate between.
Yeah, so just on that, I mean, we've talked before about a lot of the shallow coral reefs have been mapped with airborne LiDAR, so we know where the edge of the shallower reefs are. But then the next a lot of mapping data to seaward is kilometres away, and it's down around 250 metres depth. So we don't actually know where the continental slope is between those shallow coral reefs and these deeper waters.
Right, so everything in between those points has been interpolated, so we don't actually have real data.
We have no idea where the edge of the Great Barrier Reef is, down in the Swain Reefs area.
There we go.
They call sticky, by the way.
Stay.
Very sticky.
Everybody knows sticky.
It's not just the driver, it is sticky. Yeah. Okay, there's a few other things going on around here. So a few other colonies. There's now the black coral in front of us.
We can pass over that one. I think Jeremy's already looked at that one.
Oh, what's
Shell?
this? It's a cone shell. It's a cone shell, and it's got its proboscis out. So this is a living cone snail. I don't know if it's a deadly one. It doesn't look like a geograph cone, but this is the siphon that it uses to. Well, it brings. What?
If it's Australian, it can kill you.
Yeah. If it's Australian, it can kill you. Yeah. This one can kill you, there, Katie.
But if it's a cone, leave it alone.
Yeah, that's right. That's what I tell my kids. If it's a cone, leave it alone. You can see it moving around. So this could be. It doesn't look like a deadly cone, but there are fish eaters and there's piscivores. Piscivores being fish eaters, and they're the ones that have these harpoons, and they're a modified radula, which is the tooth inside a gastropod, and they can inject a toxin into the fish, kills them dead pretty quick, and they actually ingest the entire fish. And if you go to the Biopixel website, that's biopixel.tv, and look up cone snails, there's some really great footage that Richard Fitzpatrick has filmed in very high, like a 500 frame per second, and then of course it's slowed down, and you can see it happens extremely quickly, and you can see these cone snails actually kill and eat fish. It's just an amazing thing to see.
Anything else for Jeremy on this little face here?
No, I don't think so.
Yep, so Ray Rard is saying the skinny ones are usually worm eaters, so that would be vermiform, if I remember.
Okay.
Vermiform eaters, right? Worms are worms.
Yep, worms are worms.
Fishes are piscivores. Fish eaters are piscivores. Yeah, so at the aquarium at James Cook Uni is just filled with all these deadly animals, and sometimes I take people in there to show them around, when we have open day at the university, and it's got stonefish and cone shells and blue-ringed octopus and all that, and I say, what's the most dangerous animal in all these aquarium tanks? The cone shell is the most deadly. It will kill you.
And is it a neurotoxin? Is it that it stops you from breathing, or is it a poison?
I think it's a poison, but I don't know exactly. Yeah, and there's a whole at James Cook Uni. There's a whole team of people working on the venom of marine life, and it's just fascinating. Not just them, but they do all the jellyfish too, like the box jellyfish, which is the world's deadliest animal, can kill you dead in 2 minutes flat if you get enough of the tentacles on you, and irukandji, which can give you this really nasty irukandji syndrome.
And they're tiny, aren't they? They're just invisible.
Tiny. And as Jamie Seymour would say, a box jellyfish can kill you, but if you get an irukandji, well, a box jellyfish can, kill you dead, but if you get an irukandji, you wish you were dead.
The pain is meant to just be
The pain
horrendous.
is bad.
And there's a delay between getting stung by an irukandji to when you might start experiencing symptoms, isn't there?
Yeah,
That's my
yeah.
understanding. And
Yeah,
so
that's right.
You don't know you've been stung until
Well,
later.
some hours later. And I love this description. You have an impending feeling of doom. Isn't that great? You think the world is going to
The
end,
impending feeling of doom becomes an actual feeling of doom.
and then you want to
wanna
die.
Cut your leg off or whatever.
Yeah.
Stung.
Yeah. Wow, it is steep here.
Yeah.
Some big boulders. We're at 209 meters. It's 17 degrees C, and we're climbing the mountain.
Yeah. Radigar makes a good point about all the deadlies, is that they don't actually want to eat you, apart from the salties.
Yeah, saltwater
Salties
crocodiles. They definitely want to eat you.
Definitely
Yeah.
stalking you.
Yeah, very aggressive. Yeah. Yeah, most of the time, if you're stung or bitten, it's just because you've blundered into them, and it's a really amazing view, just how steep it is.
Yeah.
This thing give you a really good view right here. Trump on the
We're just
Fantastic.
doing a big
Look out to the
scan
side.
sideways.
And drop the
Oh,
lights.
wow.
Look at that.
There you
Wowee.
go.
It's just
Fantastic.
fantastic, isn't it? So that's natural ambient light. There are no lights on at the moment apart from the lasers.
Just angling up,
Just
so
have a
you
little
can see how it's
upwards.
getting a bit brighter as we head towards this, looking up into the sea surface.
Let's start focus there.
Yeah, so we're on autofocus, so sometimes it shoots out. There we go.
Here we go.
Yep, I think you'd need your crampons and ice and axe for that, don't you think,
Like
Marty?
that, isn't it? Yep. Real mountain climbing territory here.
And I'm seeing more layering going on, like that classic framework
Framework,
strata of coral reef. Lots of nooks and crannies. Because it's not an exact layer, but you think of it layer upon layer, it all, up and down. Even though you can get your eye in and think of it, that analogy I said before, the putting the
Yeah,
kitchen, the
plates on the
plate
table.
on each other.
Yeah, that's a really good
Now, what's
analogy.
this red rock here,
Is it a
Marty?
sponge?
Sponge?
I'm guessing
Just
sponge.
a recent sponge that's rolled down the hill.
It's a sponge.
So our dive we've planned today is to come up this steep western face, and then as we kind of sum it out, probably around about 100 meters, it'll start flattening, and then we'll see it. We'll be in the crest of this dive of this reef. So we're well over halfway up it now. We're at 200 meters. Got another 150 meters vertical rise here, and we're going to bring Joan and Valerie on. It's just an inset view of where we are climbing up that steep western face.
Hi everybody.
Hello again.
So, yeah, for those who have listened to the previous live streams, I'm Valerie.
And I'm Joe again. Nice
And-
to meet you all.
Yeah, we're both postgraduate students in my final semester in your
Second last semester.
at James Cook University. So we were both remote sensing students that kind of met Rob actually through our supervisor, through our projects that we were doing. So that's how we actually managed to get on here, and we've been on here for the past almost month now.
Almost a month, yeah.
Yeah.
I think 3 weeks already.
Yeah.
And
Like on one hand, it's gone by so quickly, but it also feels like we've been on this boat for, I don't know, this feels like it's been my life for a long time, so.
it's a little bit hard to tell how time passes here because we're basically, if we're diving, we're staying in the control room, in the cabin most of the time, and we don't really go out. And when it's the day that we don't dive, if we don't push ourselves, go out on the deck, we still don't know how time
yeah.
flies.
I often forget to tell myself to go outside, so I kind of get lost in this time continuum where I have no idea what day it is. Someone reminded me that it was Monday today, and I didn't even realize it was a new week. So,
Living on a boat is definitely very different.
yeah. It really is. Like, but it is a very great experience, you know. I think for both of us, experience on a big ship like this, you know, we've both worked out just because, you know, I think you feel you're on a boat a lot easier when you're on a smaller boat, whereas here I often forget I'm even at sea. You know, the stabilization on this boat is amazing, and we've been so lucky to have such good weather, so it's been really flat.
Yeah, these last 2 days, the water looked like glasses.
Yeah, it's really amazing. So we've been on the deck quite a lot looking out for dolphins or whales, which